sustainable energy under 5P principle, that is peace, planet, people, prosperity, and partnership. As a part of its approach for knowledge sharing and awareness creation, today Indian Association of Energy Management Professionals, with the support from MP Urja Vikas Nigam Limited, is celebrating the National Energy Conservation Day by organizing this workshop on sustainable energy. So without any further ado, let's start with the amazing workshop. I would like to welcome our honorable speaker, Shri Vibhucharan Swain, the General Secretary of IAEMP. He is working as a senior consultant in Powertech Consultants. He is an accredited energy auditor duly empaneled by Bureau of Energy Efficiency, Ministry of Power, Government of India, and is involved in various energy efficiency studies, energy audits in industry. He also works in the field of electricity regulatory research and policy interventions and power trading. In addition to his brilliant academic record and MTech degree from Indian Institute of Science, Bangalore, he is having around 23 years of experience in engineering, project, operations and maintenance, consultancy, and has earlier worked with reputed companies like Tata Chemicals Limited, Jindal Stainless Limited, etc. He is also co-chairman of Electricity and Power Committee of Utkal Chamber of Commerce and Industry, governing body member of Indian Association of Accredited Energy Auditor and Energy Panel member of FICCI. He is a core group member of Mission Sustainable India 2022 and the State Advisory Committee member to Honorable OERC. Sir, please speak a few words and start the workshop. I warmly welcome you, sir.
Thank you, Divyan. And my hearty congratulations to all of you on National Energy Conservation Day. Honorable Sri SP Ganayak Sir, Executive Directors, Energy Efficiency Services Limited, and Patron of IAEMP, Sri Anil Chaudhary, President IAEMP, and CGM Operations of ESL. I welcome both of you on this occasion. Today, IAEMP is celebrating its National Energy Conservation Day, and the topic we have chosen, sustainable energy, considering the climate change, considering COP26 issues, and I hope our small initiative will definitely bring good results in coming days. Now, friends, we will have a good session from Sri Sunil Sood also, who is the chief mentor. He will be discussing on the Mission Sustainable India initiative, how IAEMP in this coming 30 days has developed a vision document to tackle the sustainability issues and how to take India in the path of sustainable development. And also we'll have Central Council members. I welcome Dr. Kamala Kanan, who will be talking on energy efficiency of industrial efficiency. And also I welcome Dr. L. Ashok, Professor L. Ashok, who will also speak on e-mobility drive of India and how IAEMP is also contributing through its various life members. We have Sri Alpesh Mehta, I also welcome, and he will discuss on the sustainability issues, how Siemens Limited is driving and the sustainability of sustainable development as far as energy is concerned. And we have Sri Prabhakaran from Fluke India, who will also share his presentation on Fluke and how energy professionals can enrich themselves with the advantage of latest technologies. And we have almost now 41 members have already joined. I am sure a lot of members also will be joining shortly. We almost 30 physical members are present in Bhopal. After the physical, they also will be online. And as far as IAEMP is concerned, We are the conscience keeper to the nations on energy matters. We have started with a very small initiative 15 years back. Recently, we have celebrated our 15th anniversary, our Crystal Jubilee in a grand way. We continue to initiate all policy intervention at different forums, whether it is BLDC fan, whether it is LED lights, whether it is energy efficient motors. We initiated in 2005 to 2010, and while developing, and we distributed all these appliances to all our life members. We procured those things. So we also created a very small step, but a very bigger. We are the first mover in bringing those energy efficiency appliances into the market. So IAMP, I'm quite happy the IAMP is progressing with the latest technologies and latest futuristic technologies. Definitely, this will save all the energy efficiency drives of the country. Currently, all our team members are working in the field of IoT, in the field of also in the field of instrumentations and industrial technologies, big data. So I'm quite sure with the help of all ST members, definitely will do wonders. And I am quite sure that we have a number of centers at different levels. We have very large number of student chapters and different state chapters, and which are contributing it a lot. And I wish all success for these sustainable energy workshops. And I welcome you all. With this, I conclude. Over to Divyan.
Thank you so much, sir. It was indeed a pleasure to hear from you. I would now like to welcome our next honorable speaker, Shri Kumar Chaudhary, President IAEMP. He has completed his BTech in Electrical Engineering from IIT Kanpur and Master of Business Law from National Law University of India, Bangalore. He is a certified energy auditor, lead quality auditor. He has been working for 25 years in heavy engineering and state-of-the-art futuristic technological projects in power distribution, power reforms, quality and energy audits, and energy efficiency in industry, power utilities, and social sector. Presently, he is working as Chief General Manager and Head Operations in Energy Efficiency Services Limited and a Ministry of Power, Government of India. He has presented various lectures, speakers, presentations, publications in various national and international forums for best practices, state-of-the-art, innovative technologies in heavy industry, utilities, and reforms. He has been into philanthropic involvement in various social bodies for sustainable development. He is a technical committee member for evaluation for National Energy Conservation Awards of Ministry of Power, being awarded today. He is also a member advisory board of Technology Innovation Hub IIT Roorkee. Sir, I warmly welcome you to deliver your special address.
Thank you, Divani. Good morning, one and all. I think some sequence changing is there. Because I thought Sunil Surji will be presenting MS Head Vision document first. But this is a welcome change. So, and good morning, one and all. A happy Energy Conservation Day to all of us. This is a festive day for all energy enthusiasts. World is celebrating this day since 1991. And on behalf of IAMP, I feel privileged to have this August Assembly on this special day. This is a very August Assembly, very renowned people, starting from our Sunil Surji, SP Ganayak ji, and various other eminents who will be speaking today also. For example, Vibhu Swaji himself is a renowned figure. Kamala Kanan ji will be speaking today, Ashok Kumar ji, Magan ji, Arvind Rastogi ji, Alpesh Mehta ji, Prabhakaran ji, and the various other audience, esteemed audience who are eminent in their field. So it is going to be a very nice discussion and very overwhelming thoughts will be coming out in this entire day, because today we are having AGM also for IAEMP. And coming to this Energy Conservation Day, this day we are reaffirming our commitment. Our agenda today speaks volumes of our commitment. Energy conservation is just not one day or one event phenomena. Has to be sustainable. This is what our agenda is for, today, which actually is for the sustainable energy. This is a workshop for sustainability. So how do we identify this sustainability? Actually, UN has already defined it, that sustainable development goals are already there. We have been talking about it all the time, various times, that there are 17 sustainable goals: no poverty, zero hunger, good health, quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduce inequalities, sustainable cities and communities, responsible consumption, climate action, life below water, life on the land, peace and justice, partnership for the goals. You see, if we have to be sustainable, we have to achieve all these things. So, so we cannot, let's say, we cannot sustain localized development with poverty and inequality prevailing. And I'm just assuring you that I am not digressing while I am saying that Gandhiji also said the same. To whenever you are doing any action, to approve your action, you have to come to the Gandhian philosophy. And Gandhi ji said that in Hindi, it has said that कि मैं तुम्हें एक जंतर देता हूँ, जब भी मैं तुम्हें संदेह हो या तुम्हारा अहम तुम पर हावी होने लगे, तो यह कसौटी आजमाओ कि जो सबसे गरीब और कमजोर आदमी तुमने देखा हो, उसकी शक्ल याद करो और अपने दिल से पूछो कि जो कदम उठाने का तुम विचार कर रहे हो, वह उस आदमी के लिए कितना उपयोगी होगा? क्या उससे उसे कुछ लाभ पहुंचेगा? क्या उससे वह अपने जीवन और भाग्य पर कुछ काबू रख सकेगा? यानी क्या उससे उन करोड़ों लोगों को स्वराज मिल सकेगा जिनके पेट भूखे हैं और आत्मा अतृप्त है? एंड तब तुम देखोगे कि तुम्हारा संदेह मिट रहा है और अहम समाप्त हो रहा है. Just for the sake of those who are, because it's a pan-India workshop, so many people may not be understanding Hindi. So I will just tell that in English also in a second, that Gandhi said that I will give you a talisman whenever you are in doubt or when the self becomes too much with you. Apply the following test. Recall the face of the poorest and the weakest man whom you have been seen, and ask yourself if the step contemplated is going to be any use to him. Will he or she will gain anything by it? Will it restore him to control over his life or destiny? In other words, it will lead to Swaraj for the hungry and spirituality starving millions. Whether your action is going to do that or not, then you find your doubts and yourself in yourself, which is getting overpowering you, melts away. So that is what Mahatma Gandhi said. And you see, this energy conservation, everything is what is that? It's going to play a very big role, because it is a great equalizer. It makes us to share the resources, reaching to all equally, hence fulfilling the sustainable development goal. And while I am saying this, I am getting myself surprised that I am finding that energy conservation is that energy efficiency and all those things, and even resource conservation combined with that, because everything will lead to the conservation of energy. So we have to see what is the sustainable goal and test whether we are doing everything right or not. This is the test which we are going. We should always put ourselves on. So coming back to this technical thing, that you And this, whenever you come to the conservation and energy efficiency, you find this another resource is generated without any investment, without any building any plant or power plant and anything, without using any kind of fuel. You are generating energy by conservation and having energy efficiency. This energy efficiency and conservation also, though taken together, and those National Energy Conservation Award is being given, and which conservation and energy efficiency practices are also being judged. But these are certainly different things. Conservation will always come through your practice, and the conservation is changing your behavior. When you don't need energy, you have to you don't have to use it. Simply, if you can afford it, you don't. It doesn't mean that you have to use it. So conservation is like sharing your cab. It's like using your lighting automation system. It's not energy efficiency, but it's a conservation method. And energy efficiency is, of course, is using energy efficiency devices, where that technically the power output will divided power input will be uh, the higher the value, more the efficient thing it is. So that is the energy efficiency. That, and in various kinds of lectures, technical lectures, and various things, we all will be listening to all those things also. So, and when we go along with this energy conservation, energy efficiency, then we have to sustain ourselves, and this sustainability and various kinds of technology innovations will all require market transformations. These all market transformation sustainabilities are definitely a very stretch goals, and this transformation will require transformation of markets and society also. And this has to be faster and deeper than in past. So all kinds of technology are to be used. If these are to be achieved, these goals must leverage existing and widely deployed technologies. This gives us the scope of all kinds of technological enthusiasm, and this various upcoming technology, Internet 4.0, and these things will be coming when we will be using deploying this technology. So, and this adoption of efficient technology shall play a vital role while we are going for the sustainability of this adoption of energy efficiency measures, energy conservation measures. So we actually we see that we have to be very efficient. We have to deploy technology. We have to encourage those innovators, those who are some sound is there. So we have to see that these innovators, various kinds of technologies are widely deployed. We have to have the pilot study of that. These are to be peer proofreading also. So that these we can have built up confidence. All the society should have the confidence on those these kinds of measures. So this public movement. So this is the thing which IAMP as a conscious keeper is taking up. So so this pandemic has also taught us many things, and that is what we have learned how we can live in the minimalistic living. This when we are going for the minimalistic living, we can see that we can go for the conservation mode. So what I'm telling now is we have to see that conservation mode and energy efficiency mode should go hand in hand, and when we go for the energy efficiency measures, we will see that various kinds of investments will be required, and so where where market
साउंड
transformation
नहीं आ
will
रहा है
be
मेरे
there,
में तेरे में आ रहा
projects, various kinds of projects will be built up.
साउंड खोल
I will request that those who are not speaking can mute their mics. So when we are building up various kinds of projects, so we will have to see whether these are sustainable or not. We can come up with the various kinds of technology. We'll be discussing with the various kinds of technology. We will be discussing with the various kinds of efficient technologies also. and various kinds of projects will be built up. So we at all the times we have to see whether these are sustainable or not. For example, let's say we come with the coal-based power plant. Coal-based power, we can go with the efficient power plant also. Coal-based. What the coal-based power plant was existing 30 years back, and the other coal-based power plant which will be coming now will be maybe much more efficient. But then we have to see the sustainability also, whether these will be sustainable for the long run, whether it will be. So that kind of assessment should be there. So this is going to be the order of the day now. Whether or whatever the technology which we are using, what is the carbon footprint, whether it is sustainable in the future or not, and that kind of thing is to be done, and that is being done. Otherwise, this is what is termed as a sustainable finance also. That these projects will be funded when there will be a sustainable financing, when will be sustainability in that, and that comes the other thing of ESG, objectivated project. ESG, environmental, social, and governance. These kinds of parameters are met, then only these projects are considered to be sustainable. So ESG parameters have become very much important when we go talk about the industry projects. So and there are various kinds of things. For example, when we are going for that any let's say electric vehicles. So electric vehicles is having a charging of electric charging, but we have to see what is the source of that. So if the source is coal, then the carbon footprint is still not that low. Whether it is certainly definitely lower than what it has been in the fossil fuel, but it can be much lower if the source is the solar one. So how green is the green is also one of the concepts which when we evolve through our sustainability process will come in that. And I will like to take one example of the Riva project, where and our Delhi Metro Rail Corporation. And Delhi Metro Corporation has tied up with the Riva project, this solar project, and they are taking that power. So Delhi Metro is claiming that they are, in the daytime, they are the green metro. Means they are not using energy of the fossil fuel. So this has made Delhi Metro a more sustainable project because they have already an option of the green energy. So that kind of concept is coming, and that kind of financing is available. So we all have to think on all those lines. And very importantly, I would like to mention that Industry 4.0 is the in thing now, and the Internet of Things, IoT-based things are being deployed, and these are must. These are not just requirement or that or academic thing. If we have to move fast, we have to get into this very fast. Every passing day is a delay. It should have been done yesterday. So that kind of thing, I hope we will always be discussing during this workshop. And I wish all of the August gathering and a very happy Energy Conservation Day. Thank you, IAEMP for organizing this, and I'm very proud that our MP is organizing this and the day of AGM. Thank you very much. Thank you.
Today's wastage of energy is tomorrow's shortage. Thank you so much, sir. It was really nice to hear from you. I would request all the participants to keep their audio and video off. I would now like to welcome our next honorable speaker, Shishamiya Prasad Ganayak, our chief guest for today's ceremony and patron of IAEMP. He is presently serving as Executive Director in Energy Efficiency Services Limited, Ministry of Power, Government of India. During his 27 plus years of professional career, Shri Ganayak has served in government, bilateral and international organizations at various capacities in the field
Dipani, unmute yourself.
Thank you so much.
मैम आवाज क्लियर नहीं आ रही.
Dipani, you can speak now.
Thank you so much, sir. It was really nice to hear from you. I would now like to welcome our next honorable speaker, Shishamiya Prasad Ganayak, our chief guest for today's ceremony and patron of IAEMP. He is presently serving as Executive Director in Energy Efficiency Services Limited, Ministry of Power, Government of India. During his 27 plus years of professional career, Shri Ganayak has served in government, bilateral and international organizations at various capacities in the field of energy policy, energy management, resource conservation, etc. As Director in Bureau of Energy Efficiency, Ministry of Power, Government of India during 2010 to 2013, he managed Perform, Achieve and Thrift Scheme and Standard and Labeling Program of India. Shri Ganayak has been associated with international agencies like United Nations Organization, Asian Development Bank, World Bank, GIZ, USAID, etc. in various projects and initiatives. Shri Ganayak holds the bachelor degree in electrical engineering from Utkal University, India, and postgraduate in plant engineering from India's National Productivity Council. He is a certified energy auditor from Bureau of Energy Efficiency, Government of India, certified from Efficiency Valuation Organization as International Performance Measurement and Performance Protocol Professional and certified lead auditor in ISO 18001. He has presented and published over 50 technical papers in various national and international seminars, workshops, journals, and websites. I would like to
Switch off your audio now.
mute the audio. I would like all participants to turn off the audio. Shri Ganayak has gone through advanced training program on energy efficiency at Japan and US. So I warmly welcome you to speak a few words and share your thoughts to the gatherings.
Thank you, Javadani. I'm audible to all of you?
Yes, sir, you're clearly audible.
Yes, sir. Yes, sir. You are.
Is my PPT visible?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, everyone. Good morning. Let me, at the outset, let me congratulate all of you for this National Energy Conservation Day today. It's an auspicious day in many occasions, and thanks for this opportunity given to me by IAEMP to speak before this august audience in a very, very important context, which is not new. We have been speaking since last 3 or 4 decades on this subject, more precisely after 2000. And let me just take you through some of the commitments that have been done so far in the last concluded conference of parties meeting 26, COP26 meeting, which concluded in Glasgow recently. It happened from 31st October to 12th November, and a lot of countries did participate in that deliberations. They committed something in the very context that how this climate, how this environment, our climate society will remain safe, cold, and prosper the way it should happen. So it's a very small presentation I have made in the today's context, although it will touch upon subsequently how it is linked to the energy efficiency and all. So this is the action from the commitment and what are the realistic expectations in COP26. So the deliberations were on a very basic premise that how this climate change is adversely impacting to our societies, and particularly to the fellow citizens in each and every corner of this world. And more importantly, it is that we are growing as a nation, we are growing as an economy. So when there is a growth, there is a need for the energy, there is a need for more and more usage of the resources, and that is actually creating a detrimental impact to all concerned, and you all understand all these things. If you go back to the Paris Convention, which happened in 2015, and some scientists at that point of time said that the temperature of this world that will ultimately raise by 6 degrees centigrade. It was good that the Paris Agreement, there have been certain commitments that was made by various nations, some of the action plans, short term, long term, medium terms and all, and that actually could keep the track of the temperature rise between 2.7 to 3.7 degrees centigrade. That is what is being said by the International Energy Agency. So what we see, but this is not enough. 2.7 to 3.7 very, very detrimental. I mean, this is also a very large temperature rise, which can impact many, many things. And you all understand all these things. So that was again deliberated in a very detailed way in the Glasgow. And it was said that, can we keep it below 2 degrees centigrade? Although there was another terminology of, another target of about 1.5 degrees centigrade, whether it is to be achieved by 2030 or 2040 or so. So what we see that the Glasgow pledges with a very innovative idea of the net zero concept. I'm not going to detail on these points, but the point is here is that 1.8 degrees centigrade rise, that is what is being targeted as a cap. I mean, we should not go beyond that. So that requires a lot of actions to be taken. So there have been some commitments by the section. Let me just touch upon these 4 actions which have been spelled out, which have been adopted, which have been committed by various nations, including ours, India. One is the mitigation. So this is very, very important aspect. I think you people are all working on how to, effectively utilize the resources or reduce your energy intensity to a certain level. It is possible. So mitigation is I request those who are not speaking, please mute your microphones. Many people are listening here. So mitigation. So this is in this mitigation, action. One of the commitment parameter. 153 countries came out and they urged and they committed that they are going to strengthen the targets. Targets means in terms of more and more usage of the renewable energy, more and more adoption of the policy and action plans. Accelerated action on coal. Coal is becoming very, very important. So there is a need from the coal transition. Minimize the coal is one impact as far as India is concerned, but this is something the countries have adopted, completely phasing out the coal related operations, whether it is power generation or it is in the usage in the end use. Deforestation, I think this is also another one of the areas where a lot of commitments have been done. And in the clean energy space, the electric vehicles, that is going to gain a more important in the coming near future. And a lot of countries, including India, have come forward with their policies, with their the action plans, with their investment pattern and all these things. So clean electric vehicles is going to play a very, very important role in the transportation sector, in the sense that it will actually phase out the usage of the gasolines or the IC engines. And there is also a reduction in the methane related greenhouse gas emissions. That is also another. So these are the 4 or 5 aspects that has been talked about. And more importantly, if you just see here, strengthening the national targets. So targets in terms of the minimum energy performance standards, targets in terms of the air pollution, water pollutions and all, targets in terms of usage of the renewable energies. These are the important things which are going to play a major role in going forward. Next is the adaptation. The moment I talk about, I have to take the mitigations and all these things, we have to adapt this thing. That it means that there are 2 different different sphere in the world, in the context that there is some developed country and there are some underdeveloped or developing countries. So the countries of one side should have to come forward to support to the others. And that is the very basic premise of this. So this actually the efforts to deal with the climate impact. So in the context of the climate impact, the support to the vulnerable countries to adopt these impacts and addresses. So that means there must be a technology transfer, there must be access to the finance, there must be a collaborative approach that is needed for these adaptation processes. Otherwise, this is going to be a one-sided affair. The third important parameter here is the finance. Once we see this, because you have to involve, or we have to involve the public-private partnerships here. So public financing is needed, public raising in the funds. The government or the authorities have to spend in this. So in this area if we see that the 1.8 degree centigrade as committed in the world community, we have to adopt. So this is very, very important point. So we see that there also the pledges, whatever commitments have been given, the public sector will raise actually millions, and the private sector will come with a trillions of the US dollar that is going to be spent in the next 10 to 15 years. The most important point is the collaboration here. How are we going to collaborate? Collaborate with the international community, collaborate with the manufacturer, collaboration with the civil society, organizations like IAEMP, industry associations, and there may be and the individual citizens. So there will be collaboration from many angles. So friends, you will be seeing a lot more this kind of collaboration and actions in the next few years, probably in the next 10 years, because of this Glasgow announcement. And this is going to actually define our career path. It is going to define the energy efficiency in the country and many others. Just to touch upon few of the idea, because I prepared the slides in the morning today, just to drawing some of the numbers from somewhere. So if you see, the coal is going to play an important role. We have to phase it out, and we will be, because if you see in the Indian context, still coal is going to dominate for next 10-15 years as far as power generation is concerned. Although we have placed 500 gigawatt of the renewable energy supply, addition by 2030, which is a very daunting task. It's a very, it's a large task, because you need many, the investments would be much more larger apart from the other challenges in the grid and all these things. But 190 countries have now agreed to phase down the coal power. And this is a very important announcement. And I think somebody recently also came back to me just to get my thoughts on how this phase out of these coal power plants will actually impact to the entire economic activities of our country. Can you believe that if we just shut down 50% of our coal power plants as of now, what will actually happen? So these are the things needs to be seen. The another is the trees and the forest. I think these are very self-explanatory, but the point is that 91% of the global forests are covered by this agreement. Only 9 to 10% will be left for deforestation, but 91. So that means whenever there is a deforestation, there must be certain action of the tea plantation in some other area. So overall, the coverage would be 91%. That's the agreement says. The other one is the electric vehicles, as I said, and we are moving in a very good direction as far as India is concerned, and we see that about 30% of the vehicles that would hit to the road by 2030 would be from the electric vehicles. And I'm privileged to be a part of Energy Efficiency Services Limited, who is actually spearheading these activities in India. So this is going to be a major player or major contributor as far as climate mitigations are concerned. The another is the methane emissions related to the methane. This is a major contributor in the greenhouse gas emission after CO2.
Hello. Excuse me,
46% of these emissions covered by this pledge.
Excuse me, sir.
The new developments are carbon neutral pledge. If you just see the need for action, if you just see, so we need, I already explained this thing to you, but just to summarize, we need funding, we need partnerships, that means think tanks, expert groups, philanthropic organizations, beneficiaries could be government, private and NGOs. There must be a diversification of our actions, that is in the energy efficiency and clean energy, because we are coming from the energy efficiency and clean energy fraternity. So that is why the interest should be because there will be other actions, as I said, forestrations and all. But as our more interest and contribution are linked to the energy efficiency and clean energy area. So what is the India's commitment? The world has committed many things. So India's commitments are on these 5 aspects. non-fossil fuel energy capacity to reach by 500 gigawatt by 2030. And we have increased it from 450 to 500 now. Met 50% of its energy requirements with renewable energy by 2030. This is a very important statement, because we are growing, say, 5 to 6% every year. So you need more and more energy. But your future energy requirements, 50% of that would be coming from the renewable energy. That's the, if you see the calculations and all, this is actually a very huge number. Reduce carbon emissions by 1 billion tons from now, 2030. In this 10 years time, if I take the baseline today, so carbon emissions have to be reduced by 1 billion tons from various initiatives. Reduce the carbon intensity by 45% by 2030 over 2005 level. So earlier it was 35%. Now we have increased it to 45%, and achieve a net zero emission by 2070, which is a very, very long way to go. There will be many more initiatives to be taken. So number 5 looks like to be a very, very futuristic goal, but this is how it's at. So energy efficiency, I think you understand all these things. Let me, on this occasion of the National Energy Conservation Day, just to revise your memory, how we started this journey from 2001 to 2000, and what we call it as a post-Energy Conservation Act era. When the Act came, there are a lot of activities started, institutionalization in the form of Bureau of Energy Efficiency, state-designated agency. But more importantly, the activity changed after 2008, when we had that National Mission on Enhanced Energy Efficiency, which was a part of the Prime Minister's Action Plan on Climate Change. So there was certain amendments to the Act and launch of various programs, including the Perform, Achieve and Trade program, the Standard and Labeling program, the ECBC code. Many things came forward, but as a policy push kind of thing. So that happened. I mean, if you just compared with the ASEAN region, other countries in the ASEAN and all, India is well ahead as compared to bringing these kind of policies and to implement these things. So energy efficiency market, if you just see,
सर इंग्लिश में ना समझाओ, हिंदी में समझा दो.
I think I was told to speak in English, so let me just concentrate. We'll share this. Energy efficiency market, how it
Participants,
looks,
please keep your audios mute, so please continue.
Energy prices, economic growth and population, this is playing an important role here. This is the economy, which is actually driving this entire aspect. Government and society, that would play a major role. These are very, you understand this point. Financing is important aspect that would actually link to entire actions. So if you see, we have to create a market assets. This will come from a supply and demand of the energy efficiency things. So supply of the energy efficiency measures, that will come from manufacturers, that will come from energy servicing companies, and research and development institutions, financial institutions. Without this, without all these things, it will be actually, you cannot connect the dots. It cannot be a complete basket. Similarly, who is going to demand for this energy efficiency? Industries will definitely play a role. 50% of your energy consumption is going to this sector. Households and commercial, because people's, the money power is increasing, the purchasing power is increasing. So they will purchase more and more energy efficient appliances. So if these appliances are energy efficient, that would be good. And so there will be a demand and supply. If you just see, in the last few years, these have been certain, I just came to my mind how to put it, but there has been some vision and direction from the regulatory aspects. So we have some standards and norms for the appliances and products in the form of standard and labeling program. We have some codes for the building, public procurement policy. We have also included, particularly the GEM portal and all, the energy efficiency norms for large industries and passenger cars, fiscal measures through innovative financing funds, financing measures. Institutional, because there will be the execution. This is where we are actually a little bit lagging. I can say it, we are lagging. So although statutory bodies are there, but that is very important thing is who is going to actually implement these things in the ground level. So as ESL has been there, but ESL cannot capture the entire market as a whole. So there is a need to grow and empower the ESCOs, other energy servicing companies, to this. There should be some center of excellences. The test laboratory also plays an important role. as you understand, because for certification of the energy efficient appliances and all. So overall, if you just see the result, this is a market transformation. Market transformation in terms of penetration of energy efficient appliances in various consumer categories, new technology interventions, whether it is industry or commercial sectors or anywhere. There should be some skilled professionals who have been generated and getting some kind of contribution, giving some kind of contribution to our societies, to our nations. So overall, if you just see, more than 15,000 megawatt has been avoided in these kind of initiatives. And if you just multiply by a 7 crores per megawatt, that's the kind of money we have saved. Had it not been, probably that money would have been spent in this year. And also, there would have been a much more usage of the coal. And some skilled professionals have been developed, and energy saving to more than 100 million tons of energy, oil equivalent have been saved. So keeping all this, as I said, once you see the policy side and all these commitments, these are fine, these are at the one end. But how are we going to actually implement these things? This is the greatest challenge, because that is where the action comes into the picture. And if you just see, we did a market survey, a market assessment, and what is the energy efficiency market in the country? And it is about $12 billion. And this is our business plan from 2016 to 21 says. But once we come to that, a very large number of reasons out there why this market is not picking up. So there are certain major constraints to this, constraint to the finance, limited capacity of the public sector to take up the things, government procurement regulations are not there, perceived technology bias is also there, because if you are using a kind of technology, you are not liable, you are not coming forward to make a change of the older technology. So that means business as usual, it is going on. So many challenges are there, and you understand all these things. I'm not going to touch on this. So there was a need for a super efficient, super ESCO energy servicing company that was needed in 2008-9, and that is why ESL was there. So only in the premise, in the basic premise that it will undertake the risk of technical natures and financials and demonstrate the energy efficiency in the ESCO model. And that is where we stand at. I'm privileged to, in this forum, to share these things. We have so far, as far as electricity is only savings are concerned, more than 45 billion units of electricity per annum have been saved. And you all know about our programs. 336 crores of LED bulbs have been distributed. Some 72 lakhs of LED tube lights have been distributed. Some 23 lakhs of energy efficient fans. We have done more than 1.2 crores of street lights. The data is a little bit older. We have also intervened in 10,400 buildings in the country, and this is a very massive program. We spent about 350 crores in this particular sector to replace their energy inefficient appliances with energy efficient appliances. And we have already replaced close to 75,000 energy efficient pumps in Uttar Pradesh and Andhra Pradesh with the in the agriculture sector. Similarly, in the clean energy business, if you just see, we have installed more than 1,50,000 numbers of LED based street lights in the rural areas in few states, and 63 lakhs of solar study lamps have been distributed to the school-going children in 5 states. And this is a very innovative program. In collaboration with IIT Mumbai, this program was implemented in a span of 2.5 years, and with the involvement of the local women NGOs who actually assembled these things to parts of these lamps to get a final lamp, and that was distributed then and there. So similarly, there are e-vehicles, there are public charging infrastructures we have created. We have gone into the innovative technologies like tri-generation. So to cut a very long story short here is that these are the very much large set of initiatives that can be taken at various very different consumer categories, be it commercial sector, domestic sector, industrial sector, agriculture sector, everything. But the bottom line here is that we have to touch upon the societies. The nature, the citizens have to be benefited, and the overall environment has to be benefited. This is my last slide. I will stop it here. So there is a sustainable development initiative needs to be taken by each and everyone. So it needed, and you see the energy efficiency plays an important role in the climate change. If you just see, I was just going through some of the data by International Energy Agency. It says that your climate change things, I mean, positive climate change will happen more. I mean, it can happen 45% due to the energy efficiency. So that means it cannot be ignored. The rest of the things can come by various factors: structural change, forestrations, going to the renewable energy. But I am talking here the energy, efficient use of energy, or the energy efficiency. How we can address the loss of the resources, that is the energy, and which is importantly is that it is controllable. It is controllable by management actions, by technology and practices. If you see as an end user perspective, if you are using energy, and if that means if you use more and more energy in efficient manner, then you incur the more energy cost and you become less competitive. At the same time, national perspective, if you just add up on everything, then more fossil fuel consumption will come and more GHG emissions are. And this is a very simple story, and you understand all these things. And it is now the time to go from conversation to the actions. So conversation to the conservation. So this is the kind of path we should follow, and we are doing a good work. But this is not enough. This is not enough the way the entire world is moving and the kind of challenges we are facing. So thank you very much for this opportunity. I just tried because there are a lot of other presentations slated to be deliberated during this workshop today, but I thought that I should give you a very broad picture of the way forward in as far as the country's energy, climate change initiatives and policies are concerned. Thank you very much for the opportunity once again.
Thank you so much, sir. It was really nice to hear from you and your kind gesture for IAMP. We are quite sure IAMP feels proud to have a patron like you, and we shall continue our good work under your direction and guidance from time to time. I would now like to welcome our next honorable speaker, Dr. Kamala Kanan. Apart from being a mechanical engineer and master in business administration, he has completed his PhD in sales management and innovation from University of Swahili. He is currently working as Managing Director, Bharat Engineering Solutions, and Secretary, IAEMP Coimbatore Chapter and Central Council Member of IAEMP. Dr. Kamala Kanan Vasanthan is a top-notch technical sales leader with diverse experience working with multiple MNCs like Kelvion India, Grundfos Pumps, Caparo Engineering, and with Indian multinationals like Precol and High-Tech Diecast. He is well known at industries as a technical solution provider. He had moved up the ladder in profession from technical sales executive to director sales, service and marketing, and currently runs a startup, Bharat Engineering Solutions. He is a known face at Energy Management Fraternity and involved in 300 plus energy audits on pumps and systems and heat exchangers in Pan-India. Sir, I warmly welcome you to deliver your presentation. Sir, you are on mute. Yes, sir, you're audible now.
Thank you so much, Divani, for the warm introduction. First of all, wishing you all, my fellow IAMPians and the audience who have gathered here, a warm and happy National Energy Conservation Day. And it really gives me immense pleasure to welcome all for the sustainability workshop on pumps and heat exchangers on behalf of IAEMP and Bharat Engineering Solutions. And it was a very nice special address given by Sunilji and Sri Anilji. Thanks for it, and welcome address by Vipuji, and particularly by our keynote address given by our Ganayakji. The initiatives by EESL, 45 billion kilowatt per annum, is really a great work on sustainable development initiatives, and we sincerely appreciate from our end, and we love to grow together with EESL and be a part of EESL as a fellow IAMPians as a whole team, not only on Pan India. Let me take it up globally too, proceeding to it. presentations. We'll have a very short intro on Bharat Engineering Solutions, who we are, and key market and key products, so that you are able to reach us for any support. And we will have the next part on key reasons for inefficiency in pumps and systems, including heat exchangers. And we will check into case studies on pumps and heat exchangers. So we have seen much on me. So let me move to a short note on the company. Bharat Engineering Solutions, a glance, we are basically from Coimbatore, based out of Tamil Nadu, and we have our sales office right now at Bangalore and Chennai. Incepted in 2021 as a sister concern of BEG, whose roots goes back to 1974. It's almost around 5 decades. They were in this field of hydraulics and energy efficient solutions for almost around 48 years. And we were the authorized distributor of world-renowned brands like Deshmi Pumps, who is an 187-year-olds from Denmark, and Gia Pumps, valves, separators, and homogenizers, and Kelvion heat exchangers. All these companies together, they have been almost around 100 years old, and they have been in this field almost in India from 1921. And the Scapero HT fasteners for high tensile fasteners, and Xylem dewatering and mining pumps, which is been pipeline. So we mainly cater to food and beverages, HVAC refrigerations, power, marine, chemicals, oil and gas, and other industries. Would say any industries you name by, let it be of a food and beverage to oil and gas or chemicals or refrigerations, you would be able to see our products. We cover almost around 85% of Indian market share in plate heat exchangers market. And with regards to hygiene pumps, valves, separators, and homogenizers, we cover almost around 1/3 to 1/4 of market share, depending on the industries. So as I said, this were our office based out of Coimbatore and Tamil Nadu, and we cover pan-India supplies too from south. And we do have our service engineers based out of east too. So our key markets covers sugars, as I said, food and beverage, any process industries which you see or you need an energy saving solutions, or you have an issues on either at process or taking up the finished product to your requirements. And for example, at dairy or food industries, it's not only power but also the process requirements plays a vital role, and there we comes into picture. So some of the few customer base to mention. Thank you. So let me get into our key part. So why save energy? We do know very well that the reserve estimates is very less, 200 years to coal and 65 years to gas and 45 years to oil. And in this National Energy Conservation Day, it's once again, we need to reiterate that there is only one Mother Earth, and we need to save our upcoming generations. And we should be able to give what we receive if it possible. So coming to the key points of pumps and heat exchangers. So is it worth working on energy savings at pumps? We have multiple machineries, we have multiple equipments. So what is the need that we have to look on pumps or heat exchangers? I just like to throw a question on to the audience, if someone could open their speaker and put it out. How many pumps do you think is really manufactured globally per month, per year, or per day? I will give 15 to 20 seconds, then I proceed with the answer. It's almost around 8 lakhs pumps is being manufactured globally. 8 lakhs pumps. And it covered almost around 10% of world's electricity consumption. It's massive, right? Exactly. That is a point. And out of that, 9 of the pumps in operation are not optimized for their applications, and their energy is being completely wasted. 10% means a lot. And we would be able to save an average of 4% of global electricity consumption if we are able to change to efficient pumping solutions. Why is there an inefficiency in pump? Coming to the key topic, we will move on to the case studies immediately the next, as I have only 10 to 15 minutes. So the key issues or picture, what we see in inefficiency in not only pumps but also any other systems or machineries, is the comparison of the purchase price, not the purchase efficiency of the machineries. I could like to highlight a recent issue where I have given an offer for almost around 10 lakhs with an efficiency of almost around 89% to a known customer to me. And there has been a similar offer for the same flow and head offered by one of the competition where their purchase cost is only 4.5 lakhs against mine of 10 lakhs. And you know what is the beauty here is the efficiency of that particular pump is only 76%, exactly saying 75.4% against 89% of mine. The purchase person was not able to take a call going up with an LOE cost, life cycle cost. That is where the people have been lacking. And we could see that there has been some improvement in the purchase team too, working on life cycle cost and taking up corresponding calculations while doing the purchase. But it's to be improvised even much better. We still see that as one of the major reason, would say the primary reason, while going for inefficient supply and utilization of any machineries, including pumps. And the second major reasons what we see with regards to excess power consumption in pumps is improper selection. Normally, if you approach any dealer or distributors or any manufacturers, there will be some ready-made system available, which is being made for a particular running flow and head. And those particular models will be supplied to the customers whenever a particular requirement of flow and head has been raised. In example, this particular model CR45-4-2 is being manufactured for a flow of 42.6 meter cube at a head of 75.3 meter with an ETA pump efficiency of almost around 76.9%. And the same pump can be operated at a flow and head within the curve region of almost around 55 meter cube, but 55.9 meters. And if this particular pump is in stock, and if there is a demand from the customers, we still see that it gets supplied to the customers without explaining the customer that its efficiency is reduced to 69%. Efficiency has been reduced to 69% against the efficiency of 76.9%, for which it was actually built for. And the future of customization and supply is growing up, and 95% of products of what we supply goes customized alone. Either at least there will be a trimming of impellers, or there will be a change of motor power, or there will be of increase of size of or thickness of the casings. So every site is unique and it needs to be customized for that particular site. This is what is missing, the key major reasons of excess power consumptions and what we saw it. For example, for the same 55.2 meter cube and 55 meters, this was the model which has to be selected, which is even much higher of almost on 72% efficiency. So the selection of pumps or any machineries to plays a key vital role while going up for supply and installations and selections. Thank you. So another major reasons for excess power consumption, what we see is over design. Normally, any plant layout is designed by a particular manufacturer or designer, and then the particular design goes to the contractor. The contractor, as a safety margin, adds 10 to 15% at his end. For example, a pump of 1000 meter cube or 100 meter cube is being designed by the designer, a plant layout, during plant layout. And when it reaches contractor, he adds 10 to 15% a margin at his end because he can't risk by himself. So he adds, he's not confident over the product what he purchased to. We can take in that way. He might be confident over him. Okay. So 10 to 15% is added by the contractor at his end on the actual design. And when it reaches the subcontractor, he adds another 10 to 15%. An average of 10% we see it in overall. And when it reaches to the dealer or the manufacturer, again another 10 to 15%. So if you see an overall, what we see while we visit sites and do an energy audits over the pumps and systems, we see almost around 30 to 40% of the pumps is being oversized. An average of 30% what we see, and depends upon the kilowatt ranges too. If you're able to see here, these pumps, both the inlet and outlet pipes has been throttled. It's mainly because that this pump is being oversized against the actual requirement at this site. So the pump is throbbing, the mechanical seal has been continuously wearing out, the impeller is also is getting replaced every time. And when we visited this site, immediately what we did is to throttle the valve, no other go, because if not, he has to replace the whole pump. And we replaced these pump too with almost half the size of the pump, the kilowatt, where it was in the site. So what we do need to take care is ensure the site conditions and select pumps max of 5 to 10%, considering future requirements, future developments, and do the selections. Oversizing definitely will lead the owner to hang him like himself, like this horse. It is an unknown overload which he have to manage. So let's ensure that the system is not over designed too. And the other key reason what we find with our excess power consumption is old and inefficient. We visited a site and we found, we have been discussing with the maintenance team, and we inquired, see, we have made the site study and audit, preliminary audit with the plant. We like to check up your other parts like water intake and water displacement distribution part 2. Let's check it out. And he was much confident and stated that he has a pump which is running for 25 years, 20 years plus, and that's not been a single failure or replacement that he have made, not even a variant here from mechanical seal. We are surprised and visited the site. And when we found that pump and we saw that it's almost operating between 25 to 26% of efficiency, which is running for 20 years. Now, what is that running cost or efficiency cost that you have paid? I have this particular case study too. We will have a look on it. So it doesn't mean that a pump which is not giving you any troubles or which have not seen any issues of replacements or services is running fine. It might be running inefficient too. So please do ensure that it's been also cross-checked. And the other major reason what we found in excess power consumption is improper layout and piping. We installed a pump in a site that's in Tamil Nadu, almost around 300 kilometers from the place where I sit. The next day morning, there is a call from the maintenance engineer and also from the plant head that the pump is starving and it's not giving the required flow on head. You have did a wrong selection. We are surprised. And I immediately took my vehicle, rushed to the site, and saw that this is the layout we found there on that particular site. Will anyone be able to see where is the pump section and delivery here? Here is the section, and here is the delivery. Just with a small alteration of this particular inlet and outlet pipelines, these multiple bends, 1, 2, 3, 4, 5, 6 bends would have been reduced. These inline pumps, this particular inline pumps is manufactured in such a way that there is not even a single bend is required in pipelines. The more bends you get, the more pipelines, the length or vertical height you take, the more loss to the systems. It took a mere of 2.5 hours to rearrange these pipelines, and this pump is running still fine as on day 2. So we need to ensure that these pipelines too is being taken much care at each and every point of installations. The basic things what we say is use an eccentric reducer, not concentric, as there will be air packets getting built up at these places. And if it's of suction from below the pump, it can be taken up in this way. Reducers to be built with eccentric at bottom. And if it is of flooded pipelines, it can be taken up in a reverse options too. Yes, there is no chance of building air packets here when it is been flooded section. Similarly, inlet velocity is to be ensured that it has been between 1 to 1.5. This is for pure water, not for wastewater. Wastewater inlet velocity has to be differ, and discharge velocity has to be between 2 to 3.5 meter per second. And always do ensure that there has been 10D of that particular section point to the next bend. Always ensure long elbow instead of short elbow, which will also reduce some frictions. So as I said to you, almost from 29 to 30% cause reason for excess power consumption is over design, and other reasons covers almost on 71%. And typical power saving potential in pumping systems against the study what we have made is 41% with regards to boiler feed pump, 34% with regards to water treatments, and air conditioning there is a potential of 33%, and cooling shower pump there is a potential of 32, and process water pumps potential of 28, and cooling shower utilities and air washers correspondingly following. So if you see 41% of saving 10 kilowatt, where you could be able to use the same flow and where you be able to get the same flow and pressure at 6 kilowatt, it means a lot, right? That's it. And some of the people will be surprised there has been sudden reduction of flow. And we noticed in certain sites too, when there has been presence of entrained gases, even maximum up to 4, if you take an example of 6% here, from the flow of the max 900 meter cube to the flow of almost on 600 meter cube, with the presence of 6% of entrained gases, there is a reduction of flow. Almost 300 meter cube of flow is been reduced. So we need to ensure that there is no presence of entrained gases too in our system. And do ensure that high efficiency motors has been used. There has been multiple efficient premium motors came up, IE2, IE3, and even IE4. Do ensure the pumps has been fitted with appropriate premium efficient motors too. And coming to rewinding of motors, what we found ourselves is the rewinding with unskilled and skilled laborers, there has been difference almost around 0.5% in the efficiency of motors. And what we saw against the electrical engineering manual is efficiency drops almost on 2% with every rewinding. So ensure that this rewinding cost is being taken up at the new motor purchase. I think with some good discounts with team like EESL initiatives, we will be able to do good replacements at motors too. And this were the basic pump audit process what we do. We normally take a preliminary visit, and post to preliminary visit, the required site study, we ensure that the detailed audit is being made immediately and corresponding report is submitted. And the key point here is implementation and continuous monitoring. We always ensure that the particular recommendation is implemented and is being monitored to at least for the couple of years further too. Coming up to the case studies. Is it okay? Is the speed okay? Shall I proceed further?
Yes, sir, it is fine.
Okay.
Only thing you have need to just look into the time and you can
Okay,
continue.
done. I will close it up right now. So cold water pumps with regards to tire curing.
Only thing we have to see that for time management we have to see it.
Done, sir. Okay.
It's interesting, but time management is also important.
Got it, sir. I will close it up. I will go first. So here, with regards to a company called Apollo Tires, where we have the replacement of process cold water pumps, PCW, what we call. So 3 numbers of an X company of 210 kilowatt has been replaced with 135 kilowatt. 45 kilowatt pumps on 135. It's almost around with an ROA of 12 months. Similarly, another case study where the savings of 1,500 units per day has been achieved with a replacement of 5 pump system with 6. And similar tire curing applications in a company called TVS Tires, where they had an issues of very poor efficiency, running cost is high, and frequent seal failures with regards to particular pump. Every week or 10 days once the seal has been replaced, and those pumps too is being replaced with an efficient pump selections against the site conditions, and with a payback period of almost around 4.2 months. 13 kilowatt savings with regards to the company and 8 kilowatt savings with the second company, and maintenance cost is almost nil. Similarly, with regards to machine tool application, there has been some pumps which has been used for the coolant water circulations or coolant liquid circulations at lifting, drag conveyors, and boosting systems, where for the same flow and head in meters, we were able to save almost 1,723 kilowatt per day. And similarly, what people say, almost around 33.6 million kilogram of CO2 emission has been saved. VSW steels, similarly, a horizontal pump has been replaced with a vertical, where a 90 kilowatt pump has been replaced with 37 kilowatt. And similar at Ovid Industries, for ice bank tank applications, we did replace an old system with the extended shaft agitator with submersible mixtures with a payback period of almost from 2.5 to 3 months. Similar at Vardhaman Steels, 106 kilowatts and replaced with 63 with a savings of 43 kilowatt. Similarly at World Power of 148 at Tyson Group Electrical with the power saving of 58 kilowatt. This all kilowatts is per hour. Similarly, Indian Space Research Organization in Bangalore, the payback of almost 11 and 14 months. And coming to heat exchangers, it is nothing but the waste heat recovery, cold water inlet and hot water outlet, where we utilize the hot gas inlet that will be of any modules, and those MOCs can be made against site requirements. It can be used as an air heater, water heater, steam production, also for electricity production, and it can be used as a bypass too. It can be used in automobiles, tobacco, other industries, and these were some of the case studies where it has been used in Weizmann, where gas inlet temperature of 294 in first stage has been reduced to 118, and water inlet at 102 has been taken up at 149 degrees centigrade with a capacity of 1460 kilowatt savings. Utilized, energy is being utilized. And similarly, with the gas inlet temperature of 118, the temperature of water from 10 to 60 is being utilized. Similarly, this is at a dairy plant, where the temperature of 176 degrees centigrade has been utilized till it takes up to 40 degrees centigrade, and particular kilowatt of 84 and 164 is being utilized at heating up the water and generating steam. Similar with regards to Lipico Seal at Singapore, water and exhaust air, the particular temperature of 70 to 90 is being utilized against the Celsius of 330 to 230. Thank you all. I would like to discuss much more in details when we have time. Hope we have separate sessions too. Thanks for the time. Good day to all. Any questions, you could raise me here at your service at all time as an IAMPN. Thank you all. Over to you, Devyani. Thank you.
Thank you so much, sir. It was really an informative presentation. I would now like to welcome our next honorable speaker, Dr. L. Ashok Kumar. He was a postdoctoral research fellow from San Diego State University, California. He has completed B.Tech in Electrical and Electronics Engineering from University of Madras and his postgraduate from PSG College of Technology and MBA from IGNOU. Presently, he is working as a professor in the Department of EEE, PSG College of Technology. He has 23 years of industrial, academic, and research experience. He has published and presented 160 plus technical papers in international and national journals and conferences. He has completed 26 numbers of Government of India funded projects worth about 15 crores, and currently 7 projects are in progress worth about 7 crores. He has developed 27 products, and out of those, 14 products have been technology transferred to industries and for government funding agencies. He has created 8 centers of excellence at PSG Tech in collaboration with government agencies and industries, namely Center for Audio-Visual Speech Recognition, Center for Alternate Cooling Technologies, Center for Industrial Cyber-Physical Systems Research, Center for Excellence in LV Switchgear, Center for Renewable Energy Systems, Center for Excellence in Solar PV Systems, Center for Excellence in Solar Thermal Systems. He is also a certified chartered engineer and BSI certified lead auditor. He is also the chairman of Indian Association of Energy Management Professionals and joint secretary of Institution of Energias Coimbatore. Sir, I warmly welcome you to deliver your presentation.
Yeah, thank you, Divyani, Devi Priya. And till what time I can talk? It's 12:26 now.
So you can carry on maybe up to 10-15 minutes. 15 minutes you can carry on, sir. No issues.
Yeah, fine. Thank you. And I miss you all. And I could not come online. I mean, come offline actually. We have planned actually to come and meet you people in person to come to Bhopal. And since it is a National Energy Conservation Day, we just want to conserve energy and conserve our money. So we thought of meeting it online. And my topic would be on electric vehicle technology, and more focus will be on how this electric vehicle technology can be taken up by we energy people. Now people are talking more on how to conserve energy, and another way is to not to use this energy. And by not using this, we can go for an alternate way by using electric vehicle. So apart from doing energy auditing, we can also give input to the industry people to go for electric vehicle. Many of the industries are using electric vehicle in terms of forklifts and battery operated vehicle for smaller distances inside the premises. And apart from that, we can promote this concept of electric vehicle to industry as well as to the public. So that is the main motive of my presentation. Let me share the presentation now. Divyani, can you please tell me whether my screen is visible or not?
Yes, sir, you are sharing right now.
Yeah, I'm going to share my PPT. Hold on for a moment.
Yes, Ashok ji, your screen is visible.
Yeah, thank you, sir. Thank you. I have more slides to share, but I'm not going to talk on every slide. I'll be giving you a gist on electric vehicle technology, what are all the implementation procedures, and what are the challenges. And being an energy auditor or energy representative, what we people can do to the country by promoting the concept of electric vehicle. That is the main application of the presentation. And a small introduction to electric vehicle technology. So there are three main tasks or challenges involved in electric vehicle technology. The first one is the battery package and how long this electric vehicle can drive and the initial investment. So these three topics we people need to concentrate on. First one is battery package. Before designing an electric vehicle, we have to concentrate on what type of vehicle we want to design, whether it can be a two-wheeler, three-wheeler, four-wheeler, or whatever it may be. And the mass of the vehicle has to be taken care. And finally, what type of machine it will operate. And based on these parameters, our battery package should be designed. After designing this, these things has to be modeled properly. So if we compensate on any one of this model, the energy consumption of other component can be increased, and it may lead to increase the overall cost of the vehicle. So we have to concentrate on these three components. And you know the advantage of electric vehicle. And the electric vehicle concept, if you see the history, I have the history of electric vehicle in the corresponding slide. If you see the concept, it was there even in the World War, before the World War. But people, after the invention of ICE, internal combustion engine, and after the Industrial Revolution, people started to enjoy the ride of internal combustion engine, and they have used this till 1970. And there was a big oil crisis in the year 1970, and there were another oil crisis in the year 1990 because of the Gulf War. And during that time, people started to think in an alternate way. And you people know the R bar P ratio, reserve bar production ratio of the primary resources. And because to extend the life expectancy of these primary resources, people started to think in an alternate way, and they went for electric vehicle. This is how electric vehicle market is booming now, and this is how why people are started to invest more on electric vehicle concepts. And the benefits of electric vehicle, it is energy independent, and we have the flexibility of using this fuel. And only consideration is purchase cost. Here we energy auditor can play a major role. How can we reduce the purchase cost? And what are the charging methodology, and how we can build our own charging infrastructure to promote the concept of this electric vehicle. And now the government is giving so many monetary benefit and avenues for developing our own charging station. See, if you see in the year 2030, they have a target, like they are going to replace all the diesel vehicle by electric vehicle, and they have given, and many of the government have given incentives for people purchasing electric vehicle. So at the end of the day, every people will be having an electric vehicle by 2030. But what about the charging station? Whether can we have it or our own, or like mobile charging station? Can we have our own charging station? Yes, we can have it. If you see in many of the vehicles, they are giving the charging station when you buy an electric vehicle. But apart from that, when you go around, when you go for a long drive, how these vehicles can be charged? If I have my own charging station, if I have my own land, can I have it? If that is so, what is the avenue, market potential for that? That is where the people can concentrate on. So if you quickly, I'll go through the history. After the invention of rechargeable battery, the concept of electric vehicle came into the market. And in the year 1902, people started to manufacture this electric vehicle in mass. And as I said, till 1920, people used only this concept of electric vehicle. And slowly people moved towards internal combustion engine, and people forgot about electric vehicle completely. And 1970, again, people went back to the electric vehicle concept, and they have manufactured. This is how the history came. And there are different types of electric vehicle in the market now. If you have introduced the concept of starting by automation, then it can be called as a micro hybrid. And if you have added electric motor along with your internal combustion engine, then it can be called as a mild hybrid. We used to do some small projects for industry people as well as for the commercial by adding motor with an internal combustion engine. For example, for your Maruti 800 car, you can add your own internal combustion engine with your motor, and you can charge your battery, and you can convert that vehicle as an electric car. That is also possible. That is possible for the two-wheeler also. Since some of the students are here, they can take it as a final year project, and they can do it. And apart from that, you can also introduce the concept of IoT. The keynote speaker spoke about this IoT also. Because of that, I just want to give few points related to IoT and electric vehicle. See, you have two-wheeler and four-wheeler, and you just want to monitor certain parameters in your four-wheeler. For example, you want to monitor the engine oil, tire pressure, the condition of the battery, the condition of the AC, and many other parameters. For example, let us say 7 parameters. Only thing you need to do is add sensor to these parameter, and you can fit it in the car. And what you can do is, like, you can get the input from all the sensor, and then you can put it in a controller. That controller can be any controller like Arduino, Raspberry Pi, MSP430, any controller that is easily available in the market with a low price. And correspondingly, you can develop your own mobile app. There are so many mobile applications available that you can do it by yourself. For example, M90 Inventor app is one such app. And you can communicate your car and your mobile phone. Whenever your tire pressure goes below a particular value, that will be intimated in your mobile phone. Similarly, the engine oil, similarly, the battery. These are all the innovation you can do it. These are all the things you can convert the conventional vehicle into an automated one, and you can call it as a human thing. The caption for mg hectare, right? So these are all the types of electric vehicles. And hybrid electric vehicle, any two sources, we can call it as a hybrid electric vehicle. And now the market is focusing on how to prolong the drive, how to enhance the driving expectancy of an electric vehicle by adding an extra storages like ultra capacitor, super capacitor, fuel cells, etc. In that case, I can call that vehicle as range extended electric vehicle. Okay, and these are all the different types of electric vehicles available in the market, and these are all the kinds of electric vehicles already people are using it. For example, locomotive, golf cars, forklifts, buses, elevator, nuclear submarine, etc. And these are all the kinds of electric cars available in the market now. And this is the basic structure of an electric vehicle. Like you need a battery, and you need a transmission system, and a motor. That's it. So if you see the architecture of an electrical, hope my one second, let me go to the laser pointer. Hope my point is visible. Let us say I have this architecture. See, I have a grid. I need to get the input from the grid, and I need to charge this battery. So this battery has to be charged from the grid. And the grid, instead of grid, you can have a solar PV system or whatever the sources it may be. So from the grid, it might be AC, and that has to be converted to DC by a rectifier. And from the DC, it will be given to a boost converter. That is a converter or the voltage required by the battery, right? And apart from that, it can give supply to the auxiliary load also. So from the battery, it will be given to the motor through an inverter. Since I have used an AC motor here, I have to give it to an inverter, and that DC will be converted to AC, and I can run the machine, and the machine transmits the power to the transmission system. This inverter is the one which controls the torque and speed of the motor, right? And the electric machine, I can use any kind of an electric machine. For example, I can use a DC motor, AC motor, SRM, SINRM, switch reluctance motor, BLDC motor, hub motor, any motor. Depending on the machine I choose, this control system or the drive architecture may vary. So now people are talking about IE4 motors, right? They are claiming that the IE4 motors efficiency can be in the range of 90 to 95%. In that case, I can use the full efficiency of this electric machine, and I can increase the overall efficiency of my electric vehicle. So how do I control that? So as of now, there are so many patents available. If you have any two sources to run a machine, then it can be called as hybrid. In the year 2000, there was an automobile show. In that automobile show, approximately 23 patents were in that area of hybrid electric vehicle. Now there are so many patents available. For example, you can add electric vehicle with electric battery, super capacitors and electric battery, fuel cell based vehicle. So only thing is, I need a mode. I need an algorithm to control the storage systems. So these are all the main components of an electric vehicle: the battery, the charging port, the DC to DC converter, the motor, onboard charger, power electronics converter, thermal system, etc. So this is how an electric vehicle can work. So this is the differential transmission system, and this is being supplied by the motor. This is being driven by the motor, and motor can be controlled by a motor controller. This motor controller is the controller where we people can work upon. Still, market potential is very, very high for this motor controller. For example, BLDC motor, anyone can design. But to control that motor, we need to design a BLDC controller. Okay, and the controller gets its input from the pedal or an accelerator, and motor controller gives the input, that is the torque and speed can be controlled through this motor controller. And the motor is getting driven, charged, supplied by the battery, right? So this is the working operation. So what is an EV basically? Conventionally, I'll be having a fuel engine system and transmission system. Hybrid, along with the fuel, I have a battery source. In the case of a battery electric, I'll completely replace this fuel, and I can run this transmission system only with the help of the battery. So there are different type of structure available: series, parallel, and series parallel hybrid. I'm not going to discuss about all these things, and this we have discussed. So this is how a plug-in hybrid electric vehicle works. So normally gasoline engine will transmit the power, the fuel to the engine, and from there it will go to the transmission system. So the electric motor generator set normally will charges the battery, and finally it will act as an electric vehicle. So getting the supply only from the battery instead of from the engine. So in the case of a plug-in hybrid electric vehicle, I can replace completely with the heavy-sized battery, and I can plug in with the conventional grid, charge it fully, and I can drive it. So when you see commercially, it can available in different models. For example, if it is PHEV 20 means it can go up to 20 miles of range without charging it. Okay, so this is how we should read it. So this is one of the beautiful slide. I have a transmission system here. How you can design an electric vehicle? What are the options available? What are the market potential? What are the research opportunities for electric vehicle? See, I can concentrate on selecting any of these motors like DC motor, induction motor, permanent magnet synchronous motor, switch reluctance motors, synchronous reluctance motor. I can choose any type. Based on that, I can use a suitable topology. Like I can have a DC to DC converter, inverter, multi-level inverter, etc. And what type of switches I use in this topology? Either it could be IGBT, MOSFET, and the latest switch is SiC. I don't know how many of you have heard of this. SiC is silica carbide based switches. The problem in the existing switches or the existing power semiconductor devices are they are prone to EMI problems, electromagnetic interference. So all the vehicle will have so many converters inbuilt. So these converters will have some electromagnetic interference. To mitigate that electromagnetic interference, we need to put some filters. See, in the year 2000, Ford has written back all these costs from the customers, saying that they have EMI issue and that will spoil the ECU of the car. So EMI is a very, very serious issue. What we energy engineers can do is like the designed car, we need to measure the EMI and we need to provide solution to mitigate that EMI. There are many ways we can mitigate it. For example, we can develop a PCB based on EBG, electromagnetic band gap structure, and we can mitigate the EMI. Or otherwise, depending on the frequency range, we can include some filters. Third option is go for SiC based semiconductor devices to mitigate the EMI. And the next research issue or next market avenue is go for storage. Now the market potential is very high for lithium family battery, lithium ion, lithium phosphate. We can purchase it in bulk, assemble it, we can sell it in terms of units. Okay, so we can go for batteries, we can go for ultra capacitor, super capacitor, fuel cells, lithium batteries, nickel metal hydrate batteries, nickel cadmium. Nickel cadmium, we are not supposed to use it. You know what? Why? Because cadmium comes under ROS compliance. So instead of nickel cadmium, we can go for nickel MH. Okay, and we can choose a particular hardware for controlling the entire systems like MPU, MCU, DSP, DSC, DSPIC, and we can have different control algorithm. For example, we can implement machine learning, deep learning also. We are doing one project related to that. We can go for unmanned vehicle, right? For that, we need to implement the concept of machine learning. And if the machine wants to predict the problem in prior, if it has to react proactively, then we have to implement the concept of deep learning. Okay, it is nothing but a predictive algorithm, right? So we are working on that. We people can concentrate on these things for the market potential and researches. And these are all the different architecture, like this is the series architecture and this is the parallel architecture. And these are the major requirements of hybrid electric vehicle. I quickly go through it. So I want to develop a power semiconductor devices which can have high power density and high energy density. And it should have high torque also. It should go for long range. It should have strong autonomy. We should develop a strong motors and with a reasonable cost. These are all the current research. We have to reduce the mass, improve the hardware, go for an alternate solution for battery. Okay, nickel metal hydrate, as I said, it has a very good market scope. And these are all the different degrees of hybridization: micro hybrid, mild, full, and plug-in. And if you compare the energy loss for the conventional vehicle and the battery electric vehicle, it is huge in the case of the conventional vehicle. And we can mitigate by introducing certain hybridization. For example, micro hybrid can eliminate standby losses, and full hybrid can eliminate engine losses completely. As I said, with the introduction of IE4 motors, motors which is having an efficiency of 90%, almost this 76% engine losses can be mitigated, right? So this I have given some comparison about the efficiency. So if you see, roughly around like 23% efficiency can be achieved in electric vehicle, but in the case of conventional vehicle I can get only 13%. And because of we, the energy ambassadors or energy engineers, this generation, transmission, distributions losses can be still reduced, and this efficiency can be increased. These are all the hybrid electric vehicle objectives: maximize fuel economy, minimize fuel emissions, and minimize propulsion system, and with a reasonable cost. Quickly, I'll move on to the concept of charging infrastructure. So these are all the drivetrain component. This we have discussed. I'll quickly go to the charging infrastructure that is useful for the markets. Like before selecting a charging, we need to know what are the charging methodology. We are following certain technology, and for that we need to select a suitable converter. There are so many converters available. These are all the classifications of converter which is being used in the electric vehicle, and it has its own requirements. It should be of a lightweight, high efficiency, small volume, low EMI, low current ripple, etc. And if you see the challenges, these are all the main challenges: the storage, frequent shutdown, how to reduce the size, increase the efficiency, and suitable configuration. And apart from that, safety is one of the main aspects, because we are carrying a bomb, right? The vehicle is with the heavy sized battery. If it crashes, then that it will explode, and there might be some oil, spillage of acids also. How to avoid it? And we can increase the performance by concentrating on these parameters: acceleration, speed, range, and of course the emission. And this is also one of the beautiful concept, vehicle to grid. Assuming that my car is being charged by solar PV placed on the roof of the car. So when I come to office at around 9 o'clock, till 5 o'clock, it will be idle in the parking station. So during that time, the solar will generate energy, and that can be used for charging my battery. And after doing so, when the battery is fully charged, the power which is being generated from the solar can be given back to the grid. So that concept we call it as a vehicle to grid technology. Okay. And there are different methods of charging, like fast charging, rapid charging, turbo charging. China is claiming that they require only 15 minutes to charge it. So there are different ways in which we can change the electric vehicle charging infrastructure. We have two ways: AC charging, DC fast charging. AC charging, we have two levels, level 1 and level 2. This government is giving incentive for developing our own charging infrastructure. We people can concentrate on this. We can concentrate on how to develop a charging infrastructure, how to install it at different locations. These are all the locations government has given, like at workplace, residential fleet, like in the case of malls, theaters, parking lots, etc. These are all the limitations. We have social problem, technical problem, economical problem, and that's it. So with this, I would like to conclude. So we can concentrate on the battery management system, designing a suitable converter, designing the motor which is being used in an electric vehicle, designing an intelligent microcontroller, and how to control the overall infotainment as well as the storage system. So with this, I would like to conclude and thank the organizer for inviting me for this Energy and Conservation Day program. And also, I would like to congratulate the coordinators as well as organizers for making this event a very grand success. And if at all, if there is any questions, I will be happy to answer you people. And before I conclude, I'll just quickly give a small market. Like I'll quickly run through some of my books, which might be useful for you engineers. I'll quickly run through it. If you really want to know a particular concept, I'll be happy to share. This is my email ID and my mobile number. If you have any doubts regarding this, please ping me in this. Thank you.
Thank you so much, sir. It was really an amazing presentation. I would now like to welcome our next honorable speaker, Shri Alpesh Mehta. Shri Alpesh Mehta is the Head of Business Development and Product Portfolio Management, Distill Industries Motion Control, LV Motors with Siemens Limited. He is having more than 30 years experience in switchgear and LV motors. He has spent more than 23 years in sales and 8 years in business development. Currently responsible for LV motor business, he is an active member in various forums of IEMA, R&D, BIS, etc. He also conducts awareness session in the field of energy conservation. Today, he will share his thoughts on role of Siemens Limited in sustainability space. Sir, I warmly welcome you to deliver your presentation.
Thank you, Devyani, and good afternoon to my all friends. So yes, it is a kind of introductory session from us, and this is just to give you a glimpse about Siemens activity in sustainability field. So let me share. I hope it and just Devyani, you can confirm. You can see my screen. Yeah, can you see my screen?
No, sir, it's not visible right now.
I'm just taking an option of entire screen, so should be possible. Yes. Okay. I think now it should be possible. You can see my screen.
Yes, sir, now it's visible.
Yes, so I'm taking the theme and I would like to elaborate something on the sustainability space, what Siemens is doing and where my department comes in. So let me tell you, friends, sustainability is a very big topic today for the humanity, and everyone, not only on the country heads, but also each of us who are the manufacturers, consultants, or the end users, all of us are supposed to contribute to the possible extent on this topic of sustainability. Siemens, you know, is a more than 165 years old organization spread all across the globe. And this is one of the very important topics for Siemens, and we are contributing to the greatest possible extent from our side. So this is a common picture which many of you must have seen many a times, sustainability development goals. And as we know that there are 17 goals on which organizations, countries are working upon. Let me tell you, Siemens at a corporate level is really working hard and contributing to the greatest possible extent in all the goals. But my business, where I can make more impact, or my team can make more impact, is mainly into two goals. That is responsible consumption and production, and to some extent we can say indirectly in the fields of climate action. So as I said, everyone is responsible for this, and let me show one slide which shows that how important is this concern for all of us. You must have heard about COP26. This happened some a month before at Glasgow, and this was 26th conference. All the country heads come together, and they share their views. They share the condition of the country, and they pledge on behalf of the country. Why it is so important? Because day by day, because of the economic growth, carbon emission has been going up. And whatever damage we have done to the climate in the last 50, 60 years, it will take at least further 50 to 70 years to bring it under control. There is a statement made in this conference, and it was really looking scary. 2-degree further rise in average temperature of the globe is a death sentence for humanity. 2 degrees only. There are a lot of facts behind it, a lot of estimations behind it. What all will happen with 2 degrees, right? And if you look at all those estimations, it's really scary. So if we want to ensure that climate temperature, average global temperature doesn't rise up to this level, rather it should be curtailed where it is today. It may go up slightly, but a bit higher. But we have to ensure the temperature increase which has been happening for last more than 50 years comes under check, because by now we have developed enough wisdom that if this continues, the life humanity will be endangered after maybe 50 to 60 years. And that's why each and every country is pledging. We have seen developed countries also are pledging to bring the pollution under control, carbon emission under control. And India also is a very big contributor to this mission. And our country also is very active in this field. So we have said that will be zero, will be carbon zero, or will be net zero by 2070. And this statement is made by our Honorable Prime Minister. Now, what all my business is doing, that is LV Motor. Siemens is a very big company. There are many fields in which we are active, like social, as a part of our CSR. We are into skill development also for students which are deprived of education. So there are a lot of activities. But as I said, every country has to contribute to this. Every company has to contribute to this. Every department has to contribute to this, and every individual also has to contribute to this. And that's why I would like to take some time to let you know where we are active. We means within Siemens LV Motor business. One area where we are very careful, very cautious, is compliance to hazardous substance. As all of us know, any products which are being produced, it has got some substance which can be harmful to the nature. And there are a lot of certifications which are active. ROHS, a few of you or all of you must be doing. So products are supposed to be ROHS compliant. That means the product should be having the substance, hazardous area substance, within the set limits. Obviously, Siemens is a very responsible organization, and we are having almost all our products are ROHS compliant. Beyond which, there is something called REACH. REACH is a kind of declaration which we have to give. Is a very big topic, but as part of REACH, we have to declare to our customers which are the products in which the hazardous substance limits. So first of all, it has to be within the limits, and second, if it is whatever it is, you have to mention and give a declaration. I can tell you, we are already working upon it, and in a very short future, I would say in coming few months' time only, Siemens may become the first company in Indian manufacturers industry, who will be giving this declaration as a part of invoice. So we normally take the lead when these kind of topics come up. One has to take a step forward and others follow. So this is one area where we are very active, and we really mean that we have to contribute to this topic. Second area, we have to offer products which are beneficial to the climate. We have to offer motors which are having high efficiency, premium efficiency. Let me tell you, in somewhere around 2012, Indian standard came out with IE2, IE3 efficiency classes. They came out with some kind of classification, and by which they gave some guidelines that how can you call your motors IE2, IE3. Before that, there was no classification. So within few days or few weeks after that Indian standard was rolled out, Siemens was the first company to launch products which were IE2, IE3 class motors. Why it was so easy for us? Because we were never waiting for standards to be announced. We were always working in the direction of high efficiency motors. By the time that Indian industry matured or standards came out, Siemens was almost ready, and then we came out. We take it as a part of our responsibility that we should be ahead of time, and we really demonstrate that. So we were the first to come in IE2, IE3 efficiency classes somewhere in 2012. And maybe it took some time for others to follow us. Now, all of us know, I had an opportunity to listen to eminent speakers, and I could see someone talking about IE3, IE4 motors also. Now, what exactly IE2, IE3, IE4 motors are there? These are the classifications driven by IEC as well as Indian standards, wherein they give tolerance, manufacturing tolerance. And if you know, tolerance can be as high as 15% of the loss. Now, since the industry is maturing, now IEC has come out with one more clause, one more guidelines, regulation, that when you are saying that my motor efficiency is X, let's take an example of 95%. My motor efficiency is 95. You are supposed to have a test certificate which will demonstrate that your motor has cleared that efficiency of 95% without tolerance. This is the new addition which has come up in current year only, FY 2021 only, and this is called conformance to IEC. Since it is driven by IEC, if any product which is to conform to CE is supposed to comply with this guideline, that when someone is marking CE on the motor, that time that manufacturer is supposed to produce a type test report which will reveal that efficiency of the tested motor is more than nominal efficiency or declared efficiency. I am pleased to tell you, again, we are leading the whole industry. Siemens in India is the only company today who is offering CE conformance IE3 motors starting from frame size 71 to 315 frame. Why we do so? Because we don't do it only as a tool to enhance our product, but we take it as our responsibility towards the nature. Having good products is not the where our responsibility ends. It's our responsibility to increase technical awareness. This is the area because of which I came more in contact with BE friends, and this is the area where Siemens can use this platform and share our knowledge with the energy managers and the auditors. We are very active in this technical awareness sessions field. We conduct maybe more than 100 programs all India, partnering with International Copper Promo Association. They are there in the fields of promoting copper, but yes, it helps the high efficiency motors. And we have got a lot of sessions which we conduct for our customers also. Let me tell you, 2 years before Corona, we conducted one training program for energy auditors also. It was a full day training program. We have complete module with us, and I have a pleasure of two colleagues of mine, Atul Jugade, he takes for business development, and Prasad Hardikar, he is very active in the meetings where the Indian standards are revised. He is the one who is known face in the energy conservation field, and you can say a very good speaker. He is the faculty who takes a session for energy auditors, energy managers. If this platform offers us a chance, then maybe on this platform we can deliver virtual technical awareness programs. Minimum time required is 2 hours, and it can be as high as 4 to 5 hours. With this, I would request my colleague Prasad Hardikar to give us a glimpse about what exactly we cover in this technical awareness program. I request Hardikar to take over from here.
Am I audible, Alpesh?
Yeah, you are audible. A bit louder, please.
Yeah, so you can just forward to the next slide. So this is a pretty old slide, but the percentages have not changed significantly. In the industrial electrical energy consumption, a hopping 3/4 of it is consumed by electric motors, and therefore IE2, IE3, IE4, etc. starts making more sense all of a sudden. Next slide, Alpesh. And this is a very well-known slide. However, I will repeat it. Even for what we say a very conservative figure of useful life of 3,000 hours per annum, if you look at operating cost as a percentage of the total life cycle cost involve purchase price, installation cost, service cost, and maintenance, etc. So if you consider all this entire thing, then energy cost is a major percentage of the total life cycle cost. And this is something that we are saying even with a very conservative figure of 3,000 hours per annum. As you can see, for a very small rating, 1.5 kilowatt motor, the purchase price bears only a 2.3% significance in the total life cycle cost. And this purchase price significance wanes down to 0.9% as the rating goes to 110. While if you look at the energy cost, it goes from 96.8% significance to 99% significance as far as a percentage of total life cycle cost is concerned. And yes, it is known. At the same time, it is very rarely found to be very well practiced in the industry, that in spite of this real life situation, that a motor as a part of life cycle cost has a major cost which is contributed by its energy consumption. Most of the times purchase price is what is being concentrated upon. And this is a sad thing which happens, which has started changing, however, and we are pleased to say that this has started changing for good, but there is a long way to go ahead. Alpesh, next slide. And as Alpesh said, should we get a opportunity to be able to present in this forum as well, or similar fora whenever time is convenient? We have about energy efficiency, 3 different categories of sessions. In the basics of energy efficient motors, basics of EEMs, we cover graphical introduction to Indian as well as international motor efficiency standards. Then we talk about the CE marking guidelines, the new CE marking guideline and European Union regulation that causes that, and the significance of the CE mark for energy efficient motors. So this is something that we cover in the basics of EEMs. Then we also have a session on dispelling the myths, wherein we talk about how a higher no load current has no significance whatsoever for energy efficiency. We address a very common fallacy, which is more important, power factor or efficiency. Most of the times people go for power factor as a higher important point because it does show a reduction in the current drawn, but that is not contributing to efficiency. So we clarify that particular myth. Then we also explain why high efficiency motors may have a slightly poorer power factor as compared to a standard efficiency one. And we also give a very rigorous mathematical or circuit based proof as to why high efficiency motors will have higher starting currents and why it should be the thing that should be kept in mind when you go for higher efficiency motors. Apart from that, we also do some advanced discussions wherein we talk about what could be harmful to a user. So blind replacement of an IE2 motor with an IE3 or an IE4, how and why can it be counterproductive, and what is recommended to avoid such a counterproduction is something that we cover in around a 20-25 minute session. Then we have a module wherein we talk about how does one unknowingly end up specifying inefficiency in the motor being ordered. Most of the times it has been known that nowadays when people, the rising awareness and rising energy costs, people are interested in going for IE3 or IE4 motors. But they follow some age-old specifications drawn by some consultants way back in 1960s. And in the bargain, what happens is that the motor tends to get oversized. So we discuss every aspect of such consultant specifications, such clauses which cause for oversizing of motors and thereby inefficient operation of the motor. So you do go for an IE4 motor, but because you have restricted certain requirements of like starting current or something, your motor does not perform. And I will back it up with a proper IEC document being shown, which states that if you restrict starting currents, you may not get efficiencies higher than IE3. And finally, we close this kind of learning session with discussion on caution to exercise before running after IE4 and IE5 efficiency class motors, and what could be an alternative rather than just going for IE5 or IE4 efficiency class motors. With that, over to you, Alpesh.
Thanks, Prasad. Thanks a lot. So, friends, it was a short glimpse. So, in case there are some auditors and managers wanting to have availed this training session from Siemens, I would request this platform can be used for this. And I can assure it will be very good insight in the fields of energy conservation. That's all from our side. Thank you very much. And I must thank for offering us the time slot of 15 minutes. Thanks a lot and all the best to all of us.
Thank you, Alpesh ji. Definitely, we will offer our platform. We jointly take up all the training session in future. Thank you very much.
Thank you so much, sir. It was really an amazing presentation. I would now like to welcome our next honorable speaker, Shri R. Neelmegan, life member of IAEMP, to deliver his presentation. Shri Neelmegan is a retired electrical engineer with 32 years experience in manufacturing sector, involved in energy conservation since 1994. Have worked in corporate house like TVS in Tamil Nadu. He is BE certified energy manager, external faculty member of PCRA. He has also written a book titled Motors, a practical guide for energy conservation and maintenance in a motor. So I warmly welcome you to deliver your presentation. Neelmegan, sir. Is sir there in the meeting?
Yeah, am I audible now?
Yes, sir, you're clearly audible.
Yeah, can I present now?
Yes, sir. Kindly unmute. Yes, the bell is
Is
there.
it available now?
Yes, sir, yes, sir.
My screen is available?
Yes, sir, yes, sir.
Okay, okay. Pranam, everybody. Rather, it's good afternoon now. I think everybody will be tired. We are behind schedule also. So I have taken out 2 or 3 slides. I will make it very short. See, this is my experience as a maintenance engineer for over 3 decades. The problem we face. First, I want to tell you that. See, it is not always a cakewalk for a maintenance engineer to involve in energy conservation and efficiency activities. See, it always takes a backseat when you compare to production. When there is an investment needed for improvement in production, the management is ready to spend on that. And if there is a need for any expenditure on quality of the product, then also they are ready to spend. But when it comes to energy conservation efficiency, we have to do, it takes a backseat. We have to do a lot of convincing aspects. So in my capacity as a maintenance engineer, what I did to gain the respect of the management and to involve themselves to okay their expenditure, I'm just telling a few more few ideas which I have been given. First, cost reduction without any expenditure. That is power cost reduction without any expenditure, without any investment. What to do? The best example is DCM. That is demand side management. So what happened is, the cost of the product is decided as you know, any product has manual cost, raw material cost, electricity cost. So if the electricity cost is reduced, the unit cost is reduced, that will catch the eye of the management. So what to do for that? That is to flatten the curve, demand curve. That is to peak load the period. That is from 10 to 5 morning is the usual peak load period. So if you just study the load pattern and distribute this load to the off periods like evening or night, then the load curve becomes flattened. So what happens then? See, in most of the I can show you a case study. In consumer A, units consumed is 2,35,000. Then at 6.35 it is 14 lakhs. Then demand charges. I am taking only these two. Rest all will be constant for most of the thing. So we have a per unit cost. That is what the accounts department or the costing department do is they divide the bill amount by the unit consumed in the particular month. That is the unit cost. So for case study 1, it is 7 rupees 28 paise. Whereas consumer B, same thing comes to 8 rupees 25 paise. What is the difference? The difference is the fixed cost. The KVA cost has a higher percentage of the running cost. So what happens? Per unit cost increases. So if you by reducing this unit cost, the product electrical cost can be reduced. And this directly will be either profit, that is manufacturing cost plus profit is the selling price. So if you reduce the unit cost or the electrical component of the product, directly gain the profit will be more for the company, or the selling price can be reduced. For competition, in competition we can reduce the selling price and this will be an impact. This will turn the eye of the management to the conservation activities. This doesn't involve any investment as such, just altering some loads and see that the demand curve is flattened. You can achieve the per unit cost, a lower per unit cost, which will be beneficial. This is one part. The second part is, as I said in the second thing, one evaporator was running for one shift only. That took care of the production requirement of 3 shifts. It was a continuous running factory. It was one shift was enough for that evaporator to operate. By just shifting the operation of the evaporator from the morning hours to the night hours, I was able to reduce 110 kVA on maximum demand. So you can imagine what is this. So we surrendered 90 kVA to the EV, and benefit was taken. The cost saved was 3,70,000. So what I'm trying to say is, activities like this, when done and shown on paper, practically that saving, then the management will be inclined to spend on energy conservation and efficiency. It will be easy to approach them for any this thing. Then the next first topic is that. The next is low cost measures. The single important duty of a maintenance engineer is to measure power elaborately. That is to fix energy meter wherever possible, as more as possible, and capture the power consumed in that area. And although the running pattern of the loads of this entity, what is the running pattern? Because we take energy conservation measures in area, but if some heaters or motors run out of ordinary period, out of average, above the average, that power consumed will eat away our conservation activities. We can't stop them from operating because it will be mainly for production or convenience, comfort level places. So we can't stop that. But at least we should be able to tell the management that without this conservation activity, the bill would have been this much. So this much has been consumed more out of ordinary, and if it is not consumed, the bill amount would have been this. So that much clarity, that much proof we need. So it's it's always necessary to maintain to log in data. That is data mining. We have to have as many data as possible to support even voltage, power factor. It all comes to record that and say that what we have achieved. So with the advent of IoT, Internet of Things, and wireless communication technologies, maintaining or capturing these parameters is not a difficult task. Only thing is we should be able to know where to capture these parameters and how to correlate it with these savings and how to present it to the management. So this is the next talk. The third thing is, these are the 4 examples of what I've done. The switching of the shop floor lighting and using maximum daylight without using lighting, and fixing of starters for big motors running 50% load, another 50% load. These are small things we can do and record the savings and protect the management. So this is simple. And this second thing. The third what I'm telling you is, before going for any such activities, energy conservation or efficiency activities, we have to demonstrate first. So this I had a very good example of fixing VFDs, variable frequency drives for ID and FD fans of a 10-ton boiler, whereby it was in 1996-95. It was in infant stage. People were talking VFD only then. It was starting. Then I had a supplier. I don't want to name bluntly, but the person who talked before me, he has the link with the supplier. This supplier, when I talked to him, he offered me a demonstration unit. He said there's a demonstration unit, you can use that for a limited period of time. So what I did is I took the VFD, connected the power analyzer and connected to one of the motors, ID motor, and ran it with VFD for 4 days, and disconnected VFD and ran the unit for 4 days. Logged the power taken, all the parameters, voltage and taken, showed and proved the economics behind that, the savings behind that, then presented to the management. No wonder I got it approved, and we fitted in 2 FT fans and 2 ID fans in 2 boilers, and they were running perfectly well. So this is another type of convincing the management to get the required resources. Then in a compressor system, see, there were 2 splicing operations there, whereby we needed 7.5 to 8 kg per square centimeter. For that, the entire factory was running in 8 kg per centimeter square. So what we did was, we approached the vendor for booster pump, air booster pump, and we got a demonstration unit from him and connected to a particular area whereby this pump will boost 2 kg from 5 to 5.5. It will boost to 7.5 to 8 required, and we kept all the other activities within 5 or 5.5, which was enough. Only that section was consuming 8 kg per centimeter. So with that pump, we were able to run it for 1 week without any production problem, without any quality problem. So when convinced and convincing, because these elements we will be convinced, because we are as engineers, we are convinced that it will work well. But to demonstrate for any ambiguity, that production people will have more ambiguity, because they are always in a state like they shouldn't want the quality to suffer. They don't want the output quantities to suffer. So they will resist the change resist for any change, because while meddling with these thing improvements, they may get a bad name, or they may get targeted for low efficiency or low output or low quality. So to convince them, we get the booster, we play it for 1 week, we run it, then we ensure that there's no problem, convince them, then we put it in 2 of the procure it, and we installed it in 2 of our sections, and it was running well. So like this, first low cost, no cost changes, then low cost changes, then by getting demonstration unit demonstrating the savings, and then procuring it and fitting is another way of convincing the management. So this is 3 steps I have taken. Then the next, original equipment manufacturers. In this area, what we see is, we always tend to buy and then install and then do a energy audit and say we need that one, this one. So that is not going to work out, because they will ask, we have invested so much in this, and on top of that you need more resources, more funding for your conservation. So what is the thing? That will be a lot of argument, and there will be a lot of ambiguity between the management and things. So what best we thought did we think in 10, 15 years back we did this. So what, see, in a system, in the air handling system, for example, you say, see, we know that it is not a constant torque operation. The air requirement will vary because of the load, because 5 or 6 machines connected in the thing. When one machine is running, the air requirement will be less. All the 5 machines running will be more. So by connecting a VFD, we can save more energy. So what we did is, we had already 3 section operating in that. When we installed 4th blower for that section, we insisted the original equipment manufacturer to deliver the blower unit with VFD. So by asking that and getting the VFD with the OEM, we did energy audit and said which is the optimal level to keep and how to manipulate the speed of the blower according to the load. Then we demonstrated, we connected the energy analyzer there and demonstrated what is the units gain, what is the efficiency gain. Then after convincing that, we just fitted to all the 3 other thing also. The same thing in plastic molding machine. See, we had around 14 to 15 plastic injection molding machine, which were 25 years, 30 years old. They were running fine. But when the management decided to buy 2 more such machines, what we did was, in our knowledge of energy management and auditing, we felt in a cycle time, the hydraulic motors load is not constant. Only 40% during the clamping time, the motor was running in full load. Other thing, while moving, while engaging the material, and while retrace, it's going to 40 to 30% of the load. So what we thought was we will reduce the motor accordingly. We'll program the VP accordingly so that the motor runs in stages, thereby electricity is saved. So we connected a energy monitor there. We fitted a VFD and we just ensured ourselves that's the saving. Then, by purchasing the two new molding machines, we approached the OEM and said it has to come with a VFD. So then again also we demonstrated it and we fitted all the retrofit all the old machines.
Nobody.
So these are the few things I just want to think. And compressors. Compressors, I think we all know that for better usage of compressor and this thing, we need air accumulators fitted, installed in strategic areas that is very near the load. If accumulators are connected very near the load, the air fluctuation and air requirement will become less, thereby reducing the load on the on time of the compressors in the compressor room. So along with the compressors, we calculate how many accumulators are needed, what is the pipeline, how we are going to do the pipeline, what is the material used for the pipeline, and these accumulators will be ordered along with the compressors. Most of the compressor people are ready to deliver the compressor with the accumulators. So we get the accumulators from the compressor people, then we install it, then we go for maintenance and all this. This is a very good way of convincing the management to go about in this. So in the end, what I'm trying to say is, by taking these preliminary steps by the maintenance engineers, the management can be convinced to take up energy conservation seriously, which will lead to conducting more such energy audits and regularly take action continuously. So this is my way of doing it, and I have been doing it all my life now. So otherwise, I find most of this is on only paper. Audit will be conducted, everything will be there, it will be stacked, it will be filed, and it will be kept. So next, when the audit requirement comes, when it's a statutory to start the requirement, we dust the file, take it out, and see what is the thing. It will be only on paper. Instead of some small modification here and there, no major action would have been taken because they are not convinced. They say it's only a mandatory, you do it mandatory, and that is it. Close file. Don't come near me after that. Go look for maintenance and see that the breakdowns are minimized and update the operation. That is the only area they are concentrating. So for us as maintenance engineers, it's a very difficult task. And these are the, so I have 4 or 5 files, but I don't want to take much time during lunch. So what I'm trying to say is, by taking all these small steps, the 4 steps I have said, without any cost, with minimum cost, with demonstrating and then fitting, and with the original equipment supplier helping us with the energy saving gadgets with their products, it will be easy for an energy manager to convince and take regular steps in energy conservation and saving front. So this is all from me for now. Thank you. Thank you very much. Thank you for your time. Over to Divyan.
Thank you so much, sir. It was really nice to hear from you. I would now like to welcome our next honorable speaker, Shri Prabhakaran PV. Shri Prabhakaran PV heads the product management team at Fluke India. He is having more than 25 years experience in the service industry in different capacities of managing maintenance tools and services. He is a trained thermographer and having more than 16 years of hands-on experience in the field of power quality and energy management. During his tenure with various reputed organizations, he provided various solutions to the energy producers and consumers. He has delivered seminars representing Fluke in various events organized by FICCI, CII, CPRI, etc. on power equality, energy management, and predictive maintenance related subjects. He is also instrumental in training Fluke customers and channel partners on this subject to ensure the best usage of the tools for reducing energy wastage and improving power quality. Sir, I warmly welcome you to deliver your presentation.
Thank you, Divyani, and thank you, IAEMP, for this event. And we can, I'm just trying to share my screen, and then we will start immediately.
Good. That is another thing I forgot to speak. Maintaining a family with
Sir, is there any issues?
Yeah, there is something. I'm unable to share the entire screen. Yeah.
You may just click on the share button and then click the entire screen.
Entire screen is not getting shared. That's what I'm unable
You
to
just
do.
click on the entire screen,
Yeah.
then
Okay.
you may click on OK.
Okay. Yeah, now it is through. Is it visible now?
Not yet. Not yet.
Yes.
Yes.
Yeah. Thanks for your patience. I think we could still sustain with a 40% of our viewers from the beginning, and that means the topic is still relevant, and there is a real concern on the sustainable energy management or sustainability in energy efficiency. Having said this, I'm just very quickly giving you an introduction of the Fluke. Fluke is a 73-year-old company. Started its operation in 1948 by John Fluke Sr. And we are today represented in more than 100 countries with 3,000 employees. And in India, we have around 300 plus employees and manufacturing facilities across US, Europe, and Asia. And in our 73 years of journey, we still comply or still hold the values of John Fluke Sr., who has taught us that a customer has the right to get more than what they paid for. And we have innovated in that 73 years with various products and the innovations to help our customers to get going and implement the energy efficiency or predictive maintenance in their field of work. I'm not getting into each of the points, but some of the things like in 1948 we started, and 1977 we developed our first handheld device of multimeter, which became the first handheld multimeter in the world. And in 2019 we introduced our first acoustic imager to find the leaks in the air or the compressed air or gas leaks. And we also introduced a precision acoustic imager to detect partial discharge in 2020. I have skipped many things to safeguard the time and then sustain the rest of the viewers here. I will be talking mainly on the aspects of energy wastage happening in the industry. I have taken 3 areas, that is the heat element, because of how the heat is getting developed and because heat is waste energy or the energy formation, and how this heat can be identified and curtailed, and then the power quality, how the power quality is wasting the energy usage, and then the leakages of precision resources like steam or compressed air kind of resources. And in electrical, you will have the electrical consumption, demand management, or the distortions and overheating of components and the motors and the equipments, and the unbalancing kind of situations. All those things can contribute to the energy inefficiencies and energy wastages. And similar to the mechanical related things like excessive vibration or overheating or the poorly designed systems can drain your energy from your pocket. Similarly, pressure drops or the air compressor drops, because that also is an area of energy intense usage in the industries, because compression air is used in industries in a major way, and majority of the industries use the compressed air for various purposes, and it is considered as for the utility many a time. When it comes to the energy wastage, the power quality and the power usage is very, very critical. Even the previous speaker has rightly put, the what are the causes of energy wastage in the industries? Mainly are listed here. It can be the human and process inefficiencies. When we design optimally, we will get the energy efficiency also optimally. But same time, there is I would consider the energy efficiency is not a kind of thing which you have to learn from the textbooks and then do it. It must be a state of mind, and you have to have that mindset, right mindset, to conserve energy and sustainment. And then you can implement better practices in your life and in your facilities. That's why you can see some of the examples given here. Lights are on, but no one is at home. Okay, that is a typical condition of even in industries, like the machines are running, but nothing is getting produced. And this is a typical condition of energy wastage. If you can put a little bit of your mind and understanding, you can curtail this kind of energy wastage in a great extent. And then the operating loads exceeding its utility peak demand, because peak demand is, again, demand management is the previous speaker has put, is very, very critical. When we have the energy available for just to do our work, and maintaining the usage on the peak time or less peak time can go a long way in conserving energy and utilizing and paying less to the available energy itself. That's why this is very, very critical. And again, the worn out or the faulty loads and faulty, because as one of the speakers mentioned, that the equipment is running for 25 years without any problem. That does not mean that there is no problem, right? That way, you have to have an idea about what is the kind of condition, real condition of these equipments in place, whether that is contributing to the real energy conservation or not, whether it is wasting throughout through various other means like vibration or excessive consumption. Because when I visited one of the textile mills in Mumbai many years back, 16, 17 years back, for an audit, we realized that the entire loom facility in their facility is the motors connected in the loom were 40% more rated, that is higher rated than the required, and it was wasting around 40-45% of energy just like that. Okay, this is the idea, that is you may have to have the kind of understanding on what is happening in your facility, and you have to take the corrective actions in time. And then comes the power quality. Power quality is a big topic, but I'm just touching here. There's certain power quality issues which can really put pressure on the energy consumption and expand the need of the utility capacity requirement for your requirements. And that means you have to pay more for the existing usage of your day-to-day use. That means if the poor power quality is there, you will be paying more for your usage. Similarly, inefficient and incorrectly sized motors. See, inefficiency and incorrectly design, these two go hand in hand. That is why you have to have efficient design and efficient systems to ensure proper energy efficiency. And when Fluke is into the measurement of science. That is, we provide the accurate and dependable measuring devices for all these purposes. That's why we have the products which can help you to do the energy study or power quality study, or even kind of energy conservation or energy audit in all levels. When you have visual audit or the temperature or heat audit, or you have the air audit, or even power and energy audit, we have the complete range of products, and you will be able to get that understanding on this. And I am just expanding on the power quality, how the power quality is going to waste the energy consumption in your facility. When you have the sinusoidal waveform running in your facility, you have the power triangle, like a single, that is two-dimensional diagram. That is, you have the kVAR, kVA, and kilowatt in the system with a DPF, that is displacement power factor. The moment when you introduce the power quality or the harmonics into it, what exactly is happening to this power triangle is there is an additional component called kVARH, which is the harmonic kVA, which is coming, and it is pushing the power factor into further, and there is a term called true power factor. This true power factor is actually your power factor, and it is actually pushing the limits of your utility supply or your capacity to further, or your actual available power usage is getting reduced. This is where you will be asked to pay more, and that is what is the new electricity acts are going to implement, and some of the states are already implementing the KVA monitoring or KVA billing instead of kilowatt hour billing. This is where you will be paying more, and this is where you have to be careful. It is not just an energy audit. You may have to have the comprehensive audit, including power quality also in consideration, so that you can suggest or recommend better things to your customers. And when it comes to the power quality and energy audit, we have the complete range of products, and we just introduced one of the latest power quality analyzers from Fluke. This is the 1770 series of power quality analyzers, which is the first power quality analyzer which meets the IEC 61000-4-30 Class A Edition 3, and designed to meet Edition 4 in that category. That means it will be able to meet and give you all kind of readings and requirements based on these standards. And it also helps you to introduce or get the results according to IEEE 519 2014 standards. Okay, this is the recommendations which is going to get implemented in the coming years, and you will have to upgrade your power quality or energy efficiency or energy instruments, energy managers into the higher levels. And this also comes with the harmonic limits as per the IEEE limits or the recommendations. And similarly, it can give you the transient measurements up to 8 kV with 1 megahertz or 20 megahertz of kind of speed. And the powerful software what we attached along with this product also gives you the measurements and the reporting capabilities the way you want the reports to be. And more importantly, this also covers one important topics or the term called supraharmonics. That is one of the previous speaker talked about the alternative automotive, that is EV. When you introduce EV in large mass scale, the power quality of the utility as well as the industry in general is getting weakened. There are studies conducted by Indian Smart Grid Forum in Bangalore. There are 12 feeders they have studied, and they realized that the power quality is deteriorating very heavily wherever they have installed the EV charging stations, and it needs nearly 25 to 40% of enhanced capacity to take care of this additional infrastructure. That means we have to be extremely careful in implementing the new things, and without strengthening the infrastructure, if you implement, we will get into more problems, and sustainability will be a kind of question mark. That's why you have to have proper study and you have to have proper care before implementing these things. And supraharmonics are part of the new technologies like solar or wind turbines or even the EV charging stations. The supraharmonics are the harmonics which is beyond 9 kilohertz range, that is beyond the 50th harmonics, and that also you may have to verify and consider when you are doing all kind of implementation of facilities. And when it comes to the mechanical loads, electromechanical loads, the heat energy can be wasted, or the friction or the excess vibration or misalignment, all those can create excess pressure on the devices, and it can waste electrical energy in a great extent. That way, how to find out those heat energy is very, very critical. That's why we even recommend the energy managers or the energy auditors to go for a kind of thermal audit. And here, when the thermal audit is very, very critical for you to identify various conditions, because heat can be generated by electricity, and when there is a harmonics or imbalance, the heat can be abnormal or it can go up, and this additional heat also can kill the equipments, and the sustainability of the facility itself will be under question if you have the power quality issues and the overheating components. That's why the overheating can also reduce the lifespan of the equipments, insulation failure and component failures, and this also will contribute larger inefficiencies in your system, and uptime will be a kind of challenge, and money will be getting wasted on a daily basis if you are not taking control of it. And how can you measure this temperature without stopping the machineries? That is where we provide you the thermal images, which can be the very handy tool for you to do the thermal audit in your day-to-day life. And thermal images can show you whatever you cannot see using your own eyes. And this can give the challenges or show you the difference in temperature of every equipment, whether it is a mechanical or electrical or a kind of fuse mechanism or even the wirings. And this will give you an indication that what is happening into that facility, and you can take these corrective actions for reducing the energy wastage in your facilities. Then comes the compressed air systems. You can also see the this is considered as the fourth utility after electricity, natural gas, and water. In any facilities, this can be consuming something like 10% to 25% of the energy will be utilized for compressed air requirements. And compressed air is again generated in one location and distributed all across your facilities. That's why it can leak on the way, and it is very, very difficult for you to find out what is the kind of leak and how much energy you are losing. And interestingly, the compressed air systems or compressors are one of the weakest or the most inefficient systems used in an industrial environment. And here is the lifetime or lifespan expense of compressed air. And you can see the only 12% of the cost is involved for the equipment procurement. And 12% goes into the maintenance, and 76% of the compressed air maintenance system is the electricity bill. That means if you can save electricity bill of the compressed air, you are conserving a lot of things. And interestingly, the compressed air is getting misused or lost in the entire process in this kind of ways. That is, only 50% of the compressed air generated by compressor systems in a facility is getting into real production. And 10% of it is artificial demand. That means because of some leaks and other things, you may have to jack up the production and then get this compensated. And then the another 10% is getting into the inappropriate use. I have seen in some of the industries, even the compressed air is used to clean up themselves. Before every people going out of the facility after the shift, they clean up themselves with this compressed air. That's a mere the gross misuse of the compressed air resource, and those kind of things can be avoided by providing the appropriate mechanism or creating awareness. Similarly, the leakage. 30% of the compressed air is getting leaked because of the inefficiencies into the piping systems and the monitoring lack of monitoring mechanisms. And this is where the compressed air system can be, the compressor air audit can be one of the major point of energy conservation and energy sustainment. And how can you do this? You will have all kind of mechanism to Snoopy water to or the soap water solutions, or you will have the ultrasound scanners and other things. What we have launched is a kind of acoustic imager which can directly show you the leak points. Just like this, the leaking points can be seen from a distance using the acoustic imager. That is how we have innovated our product line to address one of the worrying energy wastage issue into the industry. Here is how the product will be running. I can just play a video 1 second to ensure that how it is working in the environment. I hope you are able to see the video with the audio.
So, if you're using an ultrasonic tube, how much training do you need? Any training for using ultrasonic?
Yeah, so I took a 2-day training. Normally it's 1-2 day or 3 to 4, depending on whether you want to become a level 1 or level 2 person inspector.
So after the training, you've had your 2-day training. Are you then able to go and start finding leaks?
You do. You can start finding leaks, but this is kind of an art, or it depends a lot on your ear. So you start getting your ear educated somehow and learning how a leak sounds like versus some other sounds. So it always requires a little bit of experience.
More experience. Before you started today, and you had to come and find leaks, how did you feel about the whole thing?
I was kind of scared. I wasn't going to find a leak.
And once you started walking around and scanning,
Yeah, it's so easy. I found so many leaks.
Yeah, this is what exactly how you can do. Instead of waiting for the experts to come and then do the audit. This imager will be able to help you to find the leaks with fraction of seconds or even less amount of time, because the air audit takes days together in even a small industry, and that can be reduced to hours in using this kind of innovative tools. And here in this video, you could have seen an expert person with the ultrasound leak detector. He took more time to find the same leak than a novice person who never used, who is not conversant with this kind of leak detection itself. And this is all from me, and I'll be summing up this with the last slide, that what we vouch here is, if you can measure, then you can manage. That means we provide you the confidence, the products which can be used to measure the energy efficiency or inefficiency in your facilities very confidently. And we also need to, apart from doing the measurement, it is the need of the hour is the appropriate design, even starting from the houses or the buildings. Building energy efficiency also is very, very important. You can't have this kind of designs, the inefficient designs, and then taking corrective actions to have a sustainable environment. And here we are offering you the complete range of products for you to have appropriate verification of temperature, electrical energy and power quality, and the air leakage. These are all from me. Thanks a lot for your active listening. Thank you. I'll be happy to answer any of the questions, if at all any. Thanks a lot. Over to Divyani. I hope I am audible.
Yes. Just a minute.
Can we ask questions, Divyani?
There's two more speakers. After that, we'll be having a question answer session.
Yeah, very nice. Thank you.
Yeah. I would now like to welcome our next honorable speaker, Shri Arvind Rastogi. He has completed his BE in Mechanical Engineering and MBA. He is a chartered engineer and BEE certified energy auditor. He has achieved a PG certificate in climate change and is pursuing PG DIP in environment and sustainability development. He has worked in corporates and engineering field for a period of 9 years. He is currently the founder and CEO of his consulting and contracting company, namely Technovations, diversified into execution of turnkey jobs in industrial instrumentation and automation, fire and gas detection and alarm systems, building management solutions, pneumatic controls. He has worked on several energy saving schemes in various process industries, including steel, cement, power, and chemical, mainly on thermal side and power drives. He is presently executing turnkey contracts with SAIL, NMDC, FSNL, NSPCL, and DRDO SFC, etc. He has traveled extensively to USA, Europe, China, Israel, and Southeast Asia. He is active on various social forums and passionate about mentoring youth and grooming them as responsible citizens. Sir, I warmly welcome you to deliver your presentation.
Sir, kindly unmute yourself.
Yeah, I have unmuted now.
Yes.
Am I live, sir? Are you able to hear me?
Yes, sir. Loud and clear.
Okay. My subject today is I want to discuss on industrial symbiosis. Sustainability development. It encompasses everything, every element, every resource that we have on our planet. Could you share the screen of my presentation, sir? Hello.
You want me to do it, or you be sharing it? Okay,
Sorry?
sir. Just a minute. You want me to do it? Okay, just a minute, sir.
Yeah, please do that, sir, kindly. Or if I have to do it, how do?
Just a minute, sir.
Oh no. Sir, is it okay now? I've done it at my end. Hello.
You are no. It is not yet visible. Kindly select. Kindly share. 1 second. Yes, it's coming. Oh, it is mine.
Is it there, sir? Is it visible?
Sir, in fact,
Yeah. Some home screen is visible. I think you can start the presentation, sir.
No, we also have a poor connection. In fact, my first slide is greetings and best wishes to all energy conservationists. Is it visible to you, sir?
Yes, sir. Now it is. I think. Dipani, can you see? I have shared. Sir, I have shared it.
No, we are not able
Yes,
to.
Yeah, power is presenting. We just saw the power is presenting.
Yeah,
some
it came,
slide
but the screen is not visible.
बैंडविड्थ का प्रॉब्लम है.
Let me do it once again.
Now we are able to see.
Okay. Just a minute. Can you see it, sir?
Yeah, I can see.
Yes, sir.
Sir, it might be the old one. You can kindly continue with that. In the meantime, I'll try.
Okay. So we now need to understand what is sustainability. In fact, one of the most classic definitions of sustainability comes from the famous document which is called the Brundtland Report, which was actually titled Our Common Future. Gro Harlem Brundtland was a former Prime Minister of Norway and a very enthusiastic environmentalist. So in 1983, the United Nations asked her to prepare a report on the state of affairs of our depleting resources and the resulting damage to the environment. So after 4 years of arduous work, a final report was published in 1987, and the report did put the developmental process in the docks with respect to the damage that was being perpetrated to our environment. And it was this report that brought eventually focus on what is called sustainable development. So out of that report emerged this definition, which I would like to read it out to you, that sustainability development is a development which meets the needs of the present without compromising the ability of future generations to meet their own needs. Now, in this context, the subject of industrial symbiosis is based on a very classic example that took place in Denmark many decades back. And till date, it remains one of the most classic examples of how sustainability development has taken place across decades and with a diverse set of industries. So let me begin with a presentation on this. Am I able to control this screen? So there is a place called Kalundborg in Denmark. I think they're going very fast. Have you put it on automatic this thing? Yeah. If you'll just help me, because I don't have the screen control. So I will request you to go along with me. I'll let you know when to
Yes,
go.
sir. Yes, sir. Kindly, sir. Yes, sir.
Please move to the next. Yeah. So this was a thermal power plant which was set up in way back in 1961, almost a 1500 megawatt thermal power plant, which was to cater to the needs of the likely industries that were to come, as well as to the Kalundborg town, which had about 3,500 homes. And here, this power plant drew its water resource from a lake nearby, which was called Lake Tissot. And obviously, in those times, since the pollution norms were already in place, so they had a flue gas desulfurization unit as well attached to this. The next slide. Subsequently, there came up a petroleum refinery, which was, I think when it started, it was Tide Water Oil, subsequently taken over by Esso, and then many years later, it was taken over by another company called State Oil. So whatever was the low pressure steam that was being generated at the thermal power plant was through a pipeline utilized in the petroleum refinery for a lot of their processes. And as a quid pro quo, what they did was that they started offering the cooling water, which was an effluent for them after treating, to be supplied to the thermal power plant. And in process, the offtake from the Lake Tissot was reduced. In the meantime, the fly ash and the clinker that was being generated was being utilized for manufacturing of cement and for the construction activities and the roads in the town. Now, we know that in these Scandinavian countries, the temperatures are very low, and most of their residences, offices, and all other units where people work and live are heated. So a part of all the waste heat from the thermal power plant was utilized for heating of the residences. And then along the course, they had these farmlands and fish farms. So a lot of heat was also given to the fish farms for maintaining the temperature there. Later on, another French company by the name of Gyproc wanted to set up a gypsum board manufacturing plant where they were mining. They had open pit mining. So this came up. They were this came up, and they had a requirement of calcium sulfate. Right. The next slide, please. Yeah. So for a lot of manufacturing process that were going on in the Gyproc plant, the waste gases comprising of methane, ethane, etc., which was utilized for the heating of the furnaces, the ovens in the Gyprox plant. Then subsequently, another industry came up, which was in the business of manufacturing of pharmaceuticals and enzymes. They also had a requirement of low pressure steam. And so this steam also is being tapped from the pipeline from the SNES thermal power plant. And whatever residue in the biological sludge that they were generating was piped to Kalundborg town and was being used there as a fertilizer, as a farm fertilizer. In the meantime, there's these gases from the petroleum refinery, whatever was being utilized by Gyprox plant, and additional surplus was also being sent back to SNES thermal power plant as a substitute for coal. So now if you look at it, a complete circular economy was gradually getting generated. The sulfur that was being, please go back. The sulfur that was being recovered from the petroleum refinery was being utilized by a sulfuric acid plant called Camera. And of course, sulfuric acid was not being required by any of these. It was being sold in the market. At the same time, the Gyprox plant also decided to capture sulfur dioxide from the flue gas desulfurization by using a scrubber. And that sulfur dioxide was subsequently utilized for manufacturing of calcium sulfate, which became as the basic raw material for Gyprox plant. This whole process started in 1961, and finally almost by 1993, they had these about 7 different manufacturing units which came up there, and there were almost 31 material exchanges that were taking place. And what is the beautiful part of this whole circular economy, if I may call it, or industrial symbiosis, was this was not under one umbrella. See, we today have a lot of references of petroleum refineries. We have a lot of references of integrated steel plants where and byproducts of one of the units are being utilized for something else. But in this particular case, these were all different units by different companies from different countries which had set up. And there was only one catalyst, and that was the municipal corporation of that particular town. So some bright people in that municipal corporation decided that we must utilize all the waste products and find out ways and means of how to utilize it and use it in the manufacturing of the subsequent industry. And the waste product from that subsequent industry was being utilized by another third industry. This way the chain got, it was a complete closed loop system that had formed. Now here is the one about the amount of waste, the type of waste that were created and the amount of waste that could have been generated, and otherwise, that they would have all resulted in huge landfills, which typically are a source site in any of the thermal plants that we see around. But in this particular case, there was not a single landfill that had been created. And if you see it, fly ash, scrubber sludge, sulfur, water treatment sludge, sulfur dioxide, carbon dioxide, all these things were subsequently utilized and by the industries there. So if you really look at it, the sustainability that was being created, and this was much before the sustainability development was actually came into being as a perspective for fighting global warming and the climate change. The next slide, please. Yeah, this is telling you the annual resources which were saved through the various exchanges and from the source that was being created, like water from Statoil, etc. Yeah, you can please go on. This was just a statistical part. Now, what I was mentioning to you, some of the most interesting features and aspects of this enterprise was that this was not originally planned as an industrial park, and the best part is there was no government intervention. All units were independent business entities who found merit and tangible benefits in cooperating with each other. So the first establishment was the SNES thermal power plant, then came the oil refinery, and then the Gyprock plant, followed by the pharmaceutical and enzyme manufacturer. Until 1993, almost 30 material exchanges were taking place, and which are taking place as of today. And the Kalundborg municipality played an active role in bringing all the stakeholders on board. Now, if you really ask me, this particular theme is not just designed and basically made to, make an emphasis on energy conservationists, but it's also on our designers, on our planners, on industrialists, and of course energy conservationists, and also our architects, because all these put together bring in their come out with and bring in their involvement in planning the whole circular economy. And the typical mantra for sustainability, which we talk of in terms of reducing, reusing, recycling, regenerating, was envisaged, was created, and was achieved in this eco-industrial park. And this is what I wanted to emphasize upon you. Wherever we have an opportunity, we must look around for the merits in whatever the waste that is being generated, and how it can be utilized by being utilized in some next industry in the vicinity. With that, I would like to close this presentation of mine. I thank you all and everyone, and my best wishes and greetings to you, to all my fellow energy conservationists on the Energy Conservation Day. Thank you very much.
This is really a nice one, sir.
It was really nice to hear from you, sir. Thank you so much. I would now like to welcome our next honorable speaker and the chief mentor of IAEMP, Shri Sunil Sood, a mechanical engineering graduate from Manit, Bhopal. He has over 43 years of experience in HVAC, air pollution control, and energy management. He is a founder member and former president of the Indian Association of Energy Management Professionals, BE certified energy auditor, and member of ASHRAE. Highly passionate and committed to energy conservation, efficiency, and sustainability, he has taken several steps to promote these concepts. He is presently working as a founder and promoter of Griha Shiksha Kendra. He is also the national convener of Mission Sustainable India 2022. So I would like to invite the respected speaker, Shri Sunil Sood, to speak a few words and to deliver his thoughts on the vision document of Mission Sustainable India 2022.
Thank you very much, Devyani, for kind words of introduction. And hello, everyone.
Hello, sir. Hello.
My voice is clear?
Yeah, very much. Clear.
Sorry.
Yeah, very well, sir.
Yeah, actually, you all know we are busy in our physical meeting, and I was one of the common factor everywhere, so couldn't come.
We have been observing you at background.
Pardon?
We have been observing you.
Oh, sir, thank you. Yes. I think by now all are tired and must be waiting for lunch. That is the best energy, so everyone is needing now. But I will just take 2 minutes about talking about Mission Sustainable India and how it is linked with sustainable energy. So today's topic, you all know that sustainable energy, what exactly we mean by this. Energy, we all know, is capacity to do work. But sustainability is working capacity. Means if you don't have the capacity, how long you can survive, how long you can work, depending on your limitations, depending on other factors, how long can you sustain? So when we talk of sustainable energy, it means it should be then, it cannot be beyond the capacity of the earth. It cannot be beyond the replenishing capacity. So it clearly means energy can be sustainable only within certain limits. In that case, we have to think, where are the energy consumed? Where is the energy being consumed? Energy is consumed to do work. Now, what are the work we are doing? Right from governance, from bureaucracy, judiciary, media, everywhere energy is consumed. Then how come we are talking of energy conservation and efficiency only within certain parameters? Finally, everything exists for whom? Industry exists for whom? Commercial building, hotels exist for whom? Who are the consumers? We are the consumer. Then governance is for whom? For us. Bureaucracy is for whom? For us. When everything is actually finally boils down to us, then can we not ask questions? What government, where the energy consumed in governance and why? What work is happening there? Why can't that work be happening in a different way, so that governance is setting the example for all others to follow? What is happening in bureaucracy? What is the energy consumption in bureaucratic structure? Why they are doing what they are doing? Can the bureaucracy be more efficient? If all these things are not settled efficient, how can we start from the tail end? So this is why we conceived the idea of Sustainable India 2022, whereby we wanted to prepare a document which will integrate all aspects of our working which require energy. And indirectly, whenever we are talking of sustainable any item, it means we are indirectly talking of sustainable energy, because no work can be done without consumption of energy. So in that case, what should be our objective? Our objective should be to see that all domains, all forms of activities happen in a sustainable manner. That is why we prepared this document. It has been in the process since almost 2 years, and since last 28 days continuously we have been having continuous discussion on this, and already 13 chapters are ready and another 7 chapters are under preparation. And our objective mainly is to see that India takes sustainable development path by 15th August 2022. Until and unless we have a clear vision on everything happening, we cannot make any activity sustainable. So that is why we created this vision document, and we have proposed certain basic structures like changes in governance, clubbing different ministries under only 4 ministries: Ministry for Planet, Ministry for People, Ministry for Prosperity, Economic Sustainability, and then Ministry for Peace and Partnership. So this is our basic structural change, which is the foundation for further structural changes in bureaucracy and in other things. And we have foreseen fourth gear of bureaucracy, fourth gear of governance and bureaucratic structure, where we have specified that there should be the selection criteria should be based on 4 P's, so that the bureaucrats who are selected, they are aligned with the sustainability. Because if you select the bureaucrats only on the basis of academic and issues related to only economic growth, they are not likely to do justice, and in the process there will not be a balanced growth. So in basic premise is that there should be equal allocation of budget, equal allocation time, equal allocation of attention. Means all 4 dimensions should get equal money, equal time, equal attention from the governance model. So this is what we are talking about. And sustainable energy, though it is the topic today, but indirectly then we are addressing all issues, so that including education, you can see the sustainable education at home, whereby we have even aligned education model with, you can see this model where Grah Shiksha Kendra model we have developed in Bhopal, where education is aligned with 5 P's. Learning for the planet, learning for people means society, learning for prosperity means learning for economy, learning for peace, and learning for working as a team together. So indirectly, if you can see this model whereby everything is being aligned with 5 P's. Yeah, you can move on. Sustainable habitat means green buildings and others, including development of cities and townships. So this is also again aligned with 5 P's. Basically, we are aligning everything with 5 P's and then ensuring that everything happens in a sustainable manner, considering the, again I said in the beginning, the replenishing capacity of the local, regional and national boundaries, as well as earth, limitation of earth to replenish anything. If the growth is happening more than the rate of replenishment, it will not be sustainable. So what we say is that we do anything which is within the replenishing capacity of Mother Earth. These blank charts, what you're seeing, is still under preparation, and by 26 January we will be completing all the work, and this vision document then will be circulated and sent to all those who are supposed to know this, and then we'll be launching campaign and awareness campaign and more intensive training programs to create more and more people who are educated about this. Already we have more than 200 people who are regularly taking part and then contributing. We wish to increase our numbers exponential soon, because as and when people are understanding this vision document, Mission Sustainable India 2022, more and more people are joining. And I'm thankful to Indian Association of Energy Management Professionals for having adopted it and given a much more now wider publicity and acceptability. And soon more and more organizations are coming forward to adopt this and make it a public document. That is what is our intention, to make it a public demand, so that public understands and demands that we want this type of model, sustainable development model. Thank you very much.
Thank you so much, sir. It was really great to know about the vision document of MSI 2022 from you. We are quite sure IAMP will contribute to the nation building under the guidance of you, Chief Mentor of IAMP. So nice of you, sir.
Thank you.
Over to you, Bibu, sir.
Now, thank you, Divyani. Really, it is very nicely presented by Susar and by other eminent panelists. We have touched almost 100, still almost we have covered, it is 223 right now, still people are there witnessing the Mission Sustainable India presented by Susar. Now we open to question and answer session. So we'll open it, and there are few queries. You can raise your queries. I think there are panelists are available who can take up those queries, or else anybody would like to. It is basically mutual exchange of ideas, mutual sharing of knowledge. So any queries, definitely you can raise your hand and put the queries. Before that, there are few queries in the chat box. Let me take those queries. And I think Ganayak has actually he has a meeting, so he went. He has gone, and but Maheshji has a queries to ESL. What is the provision to wildfire? Wildfire, yes, very difficult situations. But I think Susa would like to take up that question: wildfire, how to control wildfire, because that is where the sustainable wildlife we might not have covered. So we may cover that. sustainable wildlife in my site movement?
Yeah, we are covering under this biodiversity, under
Yes,
biodiversity.
Yes, definitely. Wildfire, fire is one of the, and unless I don't think people participate in a collective manner, it will not
Yeah,
control government making a body or regulations will not, because there are people in the jungles, there are also people who actually create a fire and to get firewood, to get charcoal. So that becomes spread. So unless we go for decentralized distribution generations and also reach to the poor family with connectivity, we reach with some kind of affordable, accessible energy sources, we may not be able to control the wildfire. And fire department, definitely we need to put all, and then people participation, public participation is very much essential to control wildfire, what I believe. Now, Shiv Naran Barma ji ka ek question tha, what are all the activities being done to increase energy efficiency? What measures taken to take care of outdated machinery at industrial level? So it is basically a question to ESL. Yes, I can take that question because ESL has come up with an industrial energy efficiency solution. Today also what we have learned to increase energy efficiency, to increase the awareness level. And in case of outdated machineries, lot of government is coming up with policies. They have come up with a vehicle scrapping policies. And I think there are a lot of waste to energy project will come, waste management system will come, where this outdated machinery will be scrapped scientifically, so that we can get copper, aluminium, segregate it, and it can go to the again manufacturing of copper, iron, and aluminium. So it will also lead to a lot of sustainable manufacturing. We don't have to mine our earth, mother earth. So mining will be controlled. So definitely outdated machinery where the enterprise, small scale MSME will come into picture. We foresee a lot of indirect and direct employment potential in case of outdated machinery of industrial level, and they can go for increased energy appliances. There is a scheme known as Market Transformation for Energy Efficiency, which intend to replace all incandescent lamps, CFL lamps, then motor. Now it is air conditioners. The future technology will become induction cooktops, then compressors. So I think the government, Bureau of Energy Efficiency, ESL, and all the ESCOs are really working hard on that. Now, standard Simnaran ji ka koi question tha, what are the standard framework being referred while doing energy efficiency audit? Yes, sir, there is a guideline by Bureau of Energy Efficiency. It is the manner and conduct for energy audit regulation 2010. The energy audit of designated consumers is being done under that regulation by Bureau of Energy Efficiency. Otherwise, it is still an evolving process. A lot of knowledge, lot of technologies are coming up. It is gradually increasing day by day. The maturity level is going forward. We are not yet matured as far as energy efficiency is concerned. So it depends upon the energy auditor capabilities, the technology, the tools we have, and I think if is there any other views, if anybody want to share, they can share that one. As far as the standard figure of energy efficiency is concerned, I am not sure about it. Yes, sir. Energy efficiency, standard framework for energy efficiency. Is there anything, maybe anybody want to, because there may be some in abroad, there might be some framework, but currently we are governed by the VE regulations and rules. Then there are few queries on the e-mobilities. I think all the pump queries have been well appreciated and explained by Kamala Kanan ji in the chat box. So I'm not going to those queries. And there is certain queries like by Uday Kumar ji, and disadvantage of battery disposal, recycling, battery life degrade faster in India. Ambient temperature is more than 25 degrees centigrade, except not for 6 months. Pollution impact of manufacturing has been taken care in net carbon. So, is there gel type maintenance free lead acid batteries are available? I think Dr. Ashok is there. You want to take any on this query? Okay. Might have left. Then some carbon saving for 1 kilometer between hybrid electrical EV and high tech petrol car. Okay. Any queries from the audience? You can ask. Yes, some hands has risen. Samsar Ali sir, you can unmute yourself and ask your queries. Ali sir.
I don't have any questions, Vibhu. Thank you very much. If it is, if the forum allows, I would like to make a statement.
Kindly, sir. Kindly. You are one of the Central Council member, life member of IAMP.
No, I'm not Central Council
No,
member.
sir. Earlier you are. So kindly, sir, put your questions.
Okay. Thank you very much. First of all, congratulations to all of you for organizing it so very well. And the topics that were selected today was really, really good, relevant to the time. Post COP26 at Glasgow, I think sustainability and terms like biofuel has again become a buzzword and talk of the town. Okay. The way things are happening all over. When I say all over, I'm talking about all over the world. I think somewhere there is a slippage in our understanding and action that happened way back in 1973 when the first world energy crisis was faced and demand side management was considered to be the apt solution. Today, world is facing much more serious concern. It is not only the energy crisis which is going to come, it is beyond that. And beyond that, whether we talk about 1.5 degree or 2 degrees centigrade rise in temperature, or a depletion of carbon spacing, or replacement of fossil fuel in another 100 years or so, it is much beyond. And every nation takes the corrective measures should have a well thought about action plan. And in that, I would like to raise one point, that is, we are today talking about the corrective measures, but we are not talking about how to switch over. Let me give you an example. Let us say in future time, after some times, if the hydrogen becomes a replenishment fuel for the power plant. Today, our power plants are all fossil fuel based. Can we replace within shortest possible time? Because even today also in our planning on the drawing board, fossil fuel based power plants are there. Today we are talking about electrical vehicle. Are we really talking about how to switch over from petrol pumps to charging stations and the consequences? And the consequences are going to be manifold on deterioration of power quality, leading to higher demand in kVA terms. So what will happen? Because of the deterioration, you will be in self-destructive mode. And second thing, for the same load, your generation capacity requirement will increase. These are the after effects and the negative consequences of what we do as for our today's planning. I think these are the things which needs to be addressed at the government level. And I congratulate IAMP people, those who are actively debating today on sustainability and talking about all these parameters. I think if not today, a time will come in future, people will recognize and appreciate IEMP. With that, I conclude. Thank you.
Thank you, sir. It is a very nice and indeed a great word from coming from you. And you nicely put forward power quality is going to be an issue in future, definitely because of non-linearities. And I'm sure with all your knowledge, expertise, we will have some solution regarding that. And we may have to conduct a separate session for this, and surely we'll do it. Now, Dr. Somu, kindly ask your questions.
Vibhuji, I think all the sessions were very informative. I think first and foremost, we should thank you, you being the architect of this agenda. So my question is to, I think Mr. Prabhakaran, he is there from Fluke team.
Yes, sir, I'm there still.
Yes, sir. Yes, sir. So, sir, my question is, you mentioned about this air audit tool, what you are having from Fluke. Can that be also used for other pressurized gases like, say, nitrogen, oxygen? You know, other than compressed air, this is also some valuable gases in many of the industrial environment they are using it. Can that be used because it is going to
Can be.
on the same
It can be used for any gases,
Wonderful.
but it will only detect the gas leaks. It will not be able to identify which gas it is leaking.
That's
And we could
that's
even
noted. Yeah.
test nitrogen. We could test helium. We could identify vacuum leaks. In fact, some of the wind turbine blade manufacturers are using this product to find out the leak happening in the when they manufacture the blade. They will do a vacuum impregnation process, and if the vacuum leakage is happening, then it is a quality issue, and even minute vacuum leak can be identified. We also supplied it for battery testing of EVs. Okay. And CO monitoring also is happening in some of the oil and gas. Reliance is one of the largest user of this product in India for oil and gas sector. And they have already, I think, 3 or 4 units purchased. And they use it for various gas identification.
Okay. Okay. Yeah. Thank you, sir. I think it is a very useful one because for all the energy auditors and the fraternity here, tools are very important. So if some latest tools are available and your session, I think you have just introduced the different tools available. Probably we can have a very detailed session from Fluke Vibhuji, so that we enrich our, the state of the art is almost changing every year. So we need to keep ourselves updated on that part. Thank you, Prabhakaran sir. Thank you.
Thank you, Dr. Samu. Thank you, Prabhakaran. Now, it is a nice one, and definitely Fluke is going to be organizational member of IAMP. I request all the ESCOs, product manufacturing company to join hands and become the organizational member of IAMP. Definitely, we will have a continued sessions, prolonged learning session for the energy manager fraternity and vis-a-vis OEM and equipment manufacturing facilities. Now, there are certain queries on by Sandeep Nisalji. What is the status of ash disposal in thermal power plant, which is spreaded over several layers, disputing farm, destroyed farming land permanently? The native farmers unfortunately leaving their places. Anybody would like to take up that question? Maybe, sir, anybody want to take up this question? Sir, there is... Rastogi sir, there is a question. You want to take up that question? Rastogi sir, Arvind Rastogi ji? Sir, unmute yourself and please.
Hello, am I audible now?
Yes, sir. Yes, audible. So there is a question by Sandeep ji. What is the status of ash disposal in thermal power plant in India, which is spread out over several layers, disputing farm, destroyed farming land? The native farmers unfortunately leaving their places. So basically, he wants to know about the ash disposal scenario as far as the government guidelines and are concerned.
Sir, I wouldn't be able to place my finger on the numbers of or the status. नहीं अब तो चालू है ना.
Yes, sir. Yes, sir.
Am I audible, sir?
Yes, sir. Audible, sir. Audible.
Yeah, audible.
Yes, audible.
So I won't be able to place my fingers on any numbers, but the fact is that fly ash is being utilized in many ways. One of them is, of course, making of fly ash bricks, which is now widely prevalent. And in fact, in most of the government projects, it has been mandated to use only fly ash bricks. That's one. So that is being utilized by around fly ash from power plants in Korba, Bhilai, as well as Raigad. These are the two things. The third thing, sir, where some additional development, although these are only on the design board, is going on, is use of sort of carbon sequestration. Where they're thinking of using fly ash along with with carbon dioxide to make certain products, as well as the making of in the construction industry as an alternative to concrete. So that trial is on, and if
Sir, when it went down, your voice is going. Yes.
Okay. This concrete today, the cement industry is this, and the construction industry, by virtue of using huge quantities of cement concrete, is the largest emitter of CO2. Not the largest, the second largest emitter of CO2. So there is a great onus and as well as emphasis on their trying to sequester carbon dioxide. And one of the way in which they're trying to do is use it along with the waste heat as well as the fly ash part from the thermal power plants. Right. So
yes, sir. Yes.
That is where it would be utilized. So these are the things that are going on.
Yes, sir.
Yes,
sir, I agree. Yes, I agree with them, sir. Even I work with Tata Power when I was in TCS. There is some mandatory rules are coming down now to use the ash minimum 20% or 40% for the brick industry. And another thing, you know that any power plant now, latest and even earlier, who has taken care of the environment, impermeable flooring to be done for the ash pond. It should not percolate. So the continuous monitoring is going on, not to percolate in the soil or sand to pollute the underground water. So those things are being monitored, and PCB also taking care. So what Sandeep is telling, okay, maybe it's there somewhere, and how to go ahead as per the PCB, we have to take care. And mainly now it is used for Portland cement and ash brick, and in future it will be reduced like anything. And mainly in lignite, no, ash percentage will be more because the young coal, so ash percentage will be more. Whereas coal, which is imported, it is less, and some coal it is up to 55% it is going ash. That is the very painful thing. We have to see how to take the fuel supply agreement, coal supply agreement, where we can reduce the ash, which is increasing your ID fan, FD fan, all auxiliary power consumption also because of ash and erosion, failure of APS, failure of ID fans. Everything can be controlled when you go for the agreement itself, fuel supply agreement itself, sir. Even if it is more, a little bit more, what is the price? That is my suggestion.
Thank you, sir. Thank you. Nicely told, sir.
Thank you.
Yes, sir, correct. And in fact, in Odisha, they have banned all the red bricks industries near the power plant. Now, PCBs are coming up with no waste water disposal. It will have to be 100% completely dry waste disposal. So those things are coming up, and already rules are there, but we need to follow the rules. Then only I think it will be possible. And my special thanks to Uday Kumar sir. He has answered all the majority of the questions, and he has in fact done a tremendous job today by sharing his thoughts, knowledge, answering the queries of the people. Thank you, sir. Thank you very much.
Thank you, sir.
It is already 3 o'clock. Now we have also our AGM at 3 o'clock. So it is a continuous sessions, and everybody is hooked up, and still we have 25 people. I'm not able to take much questions, and definitely you keep us putting in our, can follow our social media in Facebook, in LinkedIn, in Twitter. Definitely somebody in our in WhatsApp group, almost 20 questions are being answered. It is a lot of knowledge. So I request those who are not live member of IAMP, they can join IAMP. Just give a message. You can be a member within a 5-minute times through online payment gateway. It is only costing 6,000 rupees, but there will be 2 sessions. And also, I request all the organization members to become a member of IAMP. And put over to the for the closing session and photographs.
Sir, you are in mute. You are in mute.
Yes, sir. Yes, sir. Sir, over to Divyani for closing session and photograph. I request if everybody can switch on their videos, then we can take some photographs and close the sessions. If it is not uncomfortable, you can switch on your videos, please, everybody.
Yes.
I am quite thankful. We have reached almost 100 participants once while Dr. A lot of eminent panelists are speaking. And I'm sorry we could not meet time, but the knowledge is so much that I cannot stop anybody. So I want that flow should go on. And definitely, who we have curtailed, definitely we are going to have separate session, full-time sessions, and coming over. It is nicely presented. Thank you all the panelists for sharing your beautiful knowledge, thoughts, and developing and bringing IAMP to these platforms. And definitely, I can foresee a lot of growth for IAMP in future. And with Abu Labat, leadership, Anil ji, we have a dedicated central council for that, and definitely will do wonders in future. Thank you all. It is nice to have you all here, and hearty congratulations on the occasion of National Energy Conservation Day. Celebrate well, do well, conserve energy, and let us bring sustainability and take India to the path of sustainable manufacturing and sustainable lifestyles. Thank you all.
Conserve energy to preserve future.
Thank you
This
all.
was an amazing workshop, and I truly thank all our honorable speakers for their knowledge and their time. I would also like to thank our participants for attending this online workshop and showing us love and enthusiasm throughout their participation. It's time to end the session. Thank you all for joining.
Yeah, thank you. Thank you for excellent arrangement, and have a nice time.
Thank you. Thank you, everybody.
Thank you, everybody. Thank you, Mr. Pevothan. Thank you, Divyani.
Thank you.
Thank you. Thank you very much. Thank you, Devyani. It was very well conducted.